त्यांचं हे अशीन ते
Naina madam, good evening. Are you there?
Yes, good evening, sir.
Good evening. नमस्कार देशपांडे सर.
हॅलो, नमस्कार सर.
नमस्कार नमस्कार सर. कुठे आहे? बार्शीला आहात का?
उस्मानाबाद.
उस्मानाबाद घरी. बरं.
हो 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 हो.
अच्छा.
सध्या कोविड सेंटर काढलंय सर कॉलेजवर.
अच्छा, बरं तिकडे आहे. बरं.
हा, 1000 बेडचं कोविड सेंटर काढलंय.
ओके.
म्हणून रोज एक जाऊन यायला लागतं रोज एकदा.
अच्छा. बाकी ठीक आहे ना?
हा, चाललंय सर, व्यवस्थित चाललंय.
खूप दिवसांनी दर्शन झालं तुमचं.
हो, अरे तुमचं सेशन म्हणल्यावर मी खास आवर्जून आलो, म्हणलं चला
थँक्यू.
खूप दिवस झाले. बाकी व्यवस्थित आहे ना?
बस तुमचा आशीर्वाद सर व्यवस्थित सर.
तो काय तो शिवप्रसाद पाटील पण माझा एमईचा क्लासमेट आहे बरं का.
हो काय बरं
हो.
बरं नांदेड.
काल परवाच बोललो, त्याच्या मुलांनी एमएस केली ना.
हो 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 माझा स्टुडंट आहे त्यांचा मुलगा.
हो बरोबर बरोबर बरोबर.
बरोबर. आमचे
हम्म.
चांगले आम्ही वर्गमित्र PhD चे.
हो शिवप्रसाद का.
हा तुम्ही एमई चे आम्ही PhD चे. येस
आम्ही एजीजीएस ला होतो दोघं.
नांदेडला आलं लक्षात मला आलं.
हो 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 हो. बाकी तब्येत व्यवस्थित आहे ना.
एकदम छान. आता बघ कॅमेरा ऑन केल्यावर बघाच.
ओके बघणार की बघणार.
चांगलं चांगलं थँक्यू.
चालेल.
तो Nana ma'am, start करा.
Yes, sir.
Yeah, please.
A hearty welcome to one and all present here. Alamuri Ratnamala Institute of Engineering and Technology, run by Koti Vidya Charitable Trust. The Department of Computer and IT welcomes our today's guest speaker, Dr. Parikshit Mahale sir, and all the participants for 1 week online faculty development program on emerging trends in AIML. So I would like to welcome Dr. Parikshit Mahale sir, the senior member of IEEE, Professor and Head of Computer Engineering Department of Srimati Kashibai Navle College of Engineering, Pune. Sir, I request you to say a few words and share your experience with us. Most welcome, sir.
Thank you, madam. Am I audible clearly?
Yes, sir.
Yes. So, very good evening to all of you. At the outset, I am very much thankful to ARMIET College of Engineering, Naina Madam, Principal, Management, and entire team for inviting me and giving me an opportunity to share my experiences on this very interesting topic, that is artificial intelligence, machine learning, and many more things we will see in the next coming 2 hours. Before we start with the session, I have a small request to all attendees, those who are attending this online session, that always when we talk about any FDP or any invited talk, always what is important is there should be many takeaways from the session, right? So my appeal to all participants is to please note down all the questions which comes in your mind, and during the last part of our session, we will definitely I will definitely address all your questions which are there with you and noted in your notebook. Why I am appealing in the start of the session, because always it is possible, now we all are connected on this online platform, and it is possible sometime that participants are interested to ask question immediately. So not an issue at all. You can put your queries in the chat box. Chat box is always open to me whenever I deliver any talk on the online platform, so that I can address your question immediately. But anyway, if sometime in the flow it is possible that I am not able to see the chat box, so in that case definitely all your questions will be there in your notebook, and I will try to answer all your questions in the last part of our session. So this is a small request to all of you. First of all, I would like to congratulate again ARMIET for arranging this FDP on very interesting area, that is artificial intelligence and machine learning. So if you look at the title, that is emerging trends in AI and ML, right? So this is a very interesting title they have framed. So emerging trends in AI and ML. So let us first prepare the groundwork, and let us first try to make it very clear that AI and ML itself are emerging trends. And now we will see what are again emerging amongst AI and ML. So try to understand. I'm making a very clear statement. AI and artificial intelligence and machine learning are itself emerging, and my objective for next 2 hours maybe to clear all your fundamentals with respect to artificial intelligence and machine learning and so on. And definitely we will also try to see, if you look at my title of my presentation, the machine learning and data science, myths and realities. Okay, so the reason why I have selected this topic, because that entire world is now working on this very interesting field of machine learning, AI, deep learning, and so on. So the reason why I have selected this topic for the presentation, because being a researcher, being a teacher, being a individual working in this field, I know that what is going in and around, at least across the globe, and I would like to bring it to your notice that what is happening, what mistakes people are doing, especially in this field of machine learning and data science. I would like to also bring to your notice that what is the future. Like, next is the trend is AI, machine learning, deep learning. So definitely it should be it will be very interesting to know what is next. And then eventually we'll also see some very interesting, differences which are not given clearly in the literature. Like, if you look at the literature, the difference between many things is not mentioned clearly. So that also we will try to understand, and then we'll move ahead. Let me share my presentation, and please acknowledge whether my slide is visible or not. So let me share my screen, and I hope my slide is visible. Yes.
Yes, sir. Visible.
Yes, sir.
Yes. Thank you. Thank you very much. Thank you so much for your quick response. So once again, appeal to all participants to note down all the questions. So now look at the title of my presentation: artificial intelligence, machine learning, deep learning, and data science, and finally, myths and realities. Right. So now let us first try to understand where the world is moving around. When if you just try to go back before 7 years, 8 years, and 9 years, and I'm very sure that you will be in a position to analyze what was a trend, what was the situation in, let's say, 2010-12. Okay, and now let us compare the computing era, which was there in 2012 to 15, and computing era now in 2020 or 2021. Okay, so there has been lot of transformation, there has been lot of revolution, not only in terms of scalability but also in terms of many other factors. So no doubt the scalability, yes, we have been increasing with respect to population, number of users, and so on. But if you remarkably try to understand what are very interesting transformations, particularly in the field of technology, so you will realize that there has been lot of transformation in this internet technology. I hope you all are agree. Yes or no? Please put your responses in the chat box so that I will feel that yes, you are connected and you're acknowledging. So there has been a lot of transformation in the internet technology. Are you agree? Yes. So now if I will ask you a very simple question, that can you pinpoint what are the revolutions in this entire internet technology? So what are the interesting improvements, transformations, revolution? So you all will agree. The first is the internet is getting faster and faster day by day. Are you all agree? Yes or no? Yes, automation, prediction, absolutely. So we are moving. So first let us try to understand internet. Due to availability of internet at faster rate, due to availability of internet at cheaper rate, we are moving faster towards automation and digitization. Are you agree? Okay, so yes, bits to, very good, bits to GB is absolutely correct, right? So that is what is a fundamental revolution. If you you can witness from last decade, like we are moving faster, even from bits to not GB, we are moving beyond it. Now we are moving with TB, we are carrying USB drive of terabytes and so on. So now coming to this point, there has been so a lot of advancement in the broadband technology, and due to that, this internet is getting more and more stable and more faster and more cheaper. I hope you all will agree. Now nobody is crazy about internet, yes or no? Because it is, yes, we all are carrying internet in our pocket. So in the background, I don't know what is happening, I don't know how many of you are keeping yourself updated, but my request to you that again you should look into what is happening in this wireless technologies, that is 3G to 4G and 4G to 5G. So there has been a lot of standardizations going on. So one thing is that, yes, due to this internet technology transformation, as I have already discussed, from 2010 to 2020, we have been moving at very faster rate in terms of number of users and number of devices connected to internet. Are you all agree that number of internet users are increasing? Yes, 5G has arrived, okay, but not yet standardized. We are not really experiencing 5G at fullest. But if you go to some European countries and if you go to United States, you can see that 5G they are already experiencing, and now recently we have started experiencing 4G at fullest. I hope you all will agree with me. Okay, and there is a very interesting standardization body. I can put it in the chat box. GISFI. Okay, there is another standardization body, ITU. There is another standardization body, ARIP. There is another standardization body, HC. And I'm closely connected to all these standardization bodies since last more than 10 years. And these are the basically standardization bodies in telecommunication product. And you all will agree that recently we have started enjoying full services of 4G, yes or no? It's always there is a gap. I can tell you that, I have been visiting many countries across the globe. So far, fortunately, I got an opportunity to visit more than 19 countries across the globe, and I'm closely associated with many technology leaders across the globe. And I know that, yes, recently we are now experiencing complete functionalities of 4G. And now if you other side of the coin, other countries 5G is in place. So fine, it is okay. But now let us talk about, because the entire presentation which I will be talking about, my focus is going to be on Indian context. Okay, because whenever we are planning to shift our interest into these emerging trends, definitely we first have opportunity to contribute locally and then nationally and then internationally and then globally, yes or no? So second point, as number of users connected to internet are increasing, number of devices which are connected to internet are increasing, and no doubt every user, every device which is connected to internet is posting some data or downloading some data from the remote storage, that is cloud, right? So try to understand why I'm touching on this point, because it is very important that why these trends are emerging today. That is very, very important. My philosophy is, when we talk about any new technology, new trend, new programming language, new programming paradigm, new database, anything, what is important, and my appeal to you all, that you should first understand why it is replaced, why it is emerging. Is it clear? And then only you will feel more interesting to look into it, how it works, and then you can start using it. So now next is, as this transformations and scalability and number of users, the data which is there, which is posted on the cloud, is increasing at faster rate. And DBMS, the word, it is very known to you all, I hope. DBMS is database management and systems. So DBMS, storing data, extracting data, transforming data, loading data, ETL is not the issue today. I hope you all are agree with me, right? So what is the issue now? If DBMS is not the issue, because storage is not the issue, that, because credit goes to, again, advancement in the semiconductor industry, and memory is getting cheaper and cheaper day by day. I hope you all are agree with me that memory is getting cheaper and cheaper day by day. Yes or no? Please be responsive in the at least chat box. I know there are some limitations of this online platform, But yes, you all will agree with me that just go before 7 years and see that 2 GB pen drive was costing how much, and now same 2 GB pen drive is costing how much today. Are you getting? So memory is also getting cheaper and cheaper. So space is really not the issue for even IT leaders. Okay, forget about individual. Is it clear? So what is issue now? Issue is how to make sense out of this big data. Most important challenge is how to draw meaningful insights from this big data. And that is what entire world is moving ahead. Okay, I can tell you that even you never know what will happen in the next 1 decade. I will touch upon it in the next part of my presentation. Okay, so you can see there are two logos on my first slide of the presentation. First is Srinagar Institute, where currently I am working since last more than 16 years, and before that I was working with VIT for 5 years. So I'm in this teaching industry since last more than 21 years. And you also know those who are in this teaching industry since last more than 15-20 years, they are also witnessing a lot of transformations in the teaching industry, especially you know that what is happening ups and downs, and I hope you all are agree. We also have any senior people attending this session, so you know that this same trend will also continue in the technology era, right? You can see another logo, which is logo of Savitribai Phule Pune University. I also represent Pune University, Savitribai Phule Pune University in various capacities. So let's move ahead. This word AI. Okay. So I don't know now. You know there are again a limitation due to limitation of this online. Platform. We are not able to see properly each other, so I cannot figure out the age group of the participants, but sometimes it's good, sometimes it's bad. But this word AI is not new. Are you agree? And that's what, you know, my always philosophy is to keep you you know, responsive, so that you at least you can put something in the chat box and I can hear you through, you know, text messages. Yes, so word AI is not new. Then let us try to understand what is new in the AI. Even I can tell you, when I was student of my engineering, I studied this subject in, you know, 95, 96, 97, 97 or 98, sometime that, you know, that time when I was doing my engineering. But objective of that subject was different. Objective of that subject when it was there in 90s was to bring some amount of, you know, intelligent artificially, okay, bring imparting intelligence artificially in some mechanical operations. Is it clear? I hope you don't know how many of you are aware A star algorithm, A star algorithm, and then monkey banana problem and so on. So this was a notion of this subject when it was there in 1990s, 95, 92, 2000, 2005, right? I can see something in the chat box. Yes. Okay. But now the objective notion of this subject is completely changed. And now the main objective of this subject is basically towards data mining. So you can see here, we'll also see the history of AI, and then we will move towards another interesting part of the discussion, that is basically a core branch of computer science. Now it is working on data mining, because ultimate objective is not to bring that intelligence. Yes, Lendrich book contains, absolutely correct, right? So that was the same book which was there in the syllabus, right? So now the notion is shifted from this, you know, bringing intelligence artificially to the mechanical operations, but the objective is towards more of data mining, and that is also called as AI. So one example here I have posted on the slide, that is spam email. You know, when we want you know, our email to be classified, that was not a really problem earlier, but nowadays it is becoming a problem due to this increasing data, increasing user, and most of the time we experience that our important mail goes to spam and non-important mail comes to inbox, right? So this is one of the use case. I'm giving it to you in order to understand you all how this AI has been transforming from 90s to 2020. Is it clear? Okay, and then we will see something on the next slide. So let's try to understand what this slide is talking about. Anyone? Can you tell me what is the objective of this slide? What this slide is talking about? Yes. So this slide is basically giving you a main objective of artificial intelligence, and main objective of artificial intelligence today is to replace this human being by a brain of the machine like this. So basically objective is to replace human brain by computing machine. Is it fine? So when we talk about this very interesting task, try to understand now. If you try to understand what human brain can do, then you will understand what you are expecting a machine to do. Is it fine? So what human brain can do? Human brain can decide, learn, memorize, predict, forecast. Yes or no? Okay, so same thing we are expecting today to be done by machine. I hope all of you understood. Many of the times, what is AI is asked, right? So try to understand what is AI. AI is just a branch of computer science which helps machine to mimic like a human brain. Definitions are there on the next slide. Don't worry. I don't believe in this theoretical knowledge. Try to understand it practically. Okay, so what is entire world is looking for replacing this human brain by machine. So you can think of now how many challenges do we have in the coming future. Is it fine? So when we talk about the next part, that when we talk about, when you are replacing this human by machine, do you think that just for sake of fun I will replace human by machine? Yes? Not really. I will first analyze the situation. What is my appeal to you all? You should analyze the situations, you should analyze the applications where you really have to replace human being by machine. Are you getting my point? Okay, means you will decide some niche areas, you will decide some critical applications where you have to replace human by machine. Are you getting? There you will not replace any application human by machine. Are you getting? So let us first try to understand some situations where you want to replace human by. Anybody can throw light on this, that when you want to replace human by machine? Anyone? Because nowadays the entire world is moving toward digitization and automation, but every digitization and automation does not require human to be replaced by machine. Yes or no? Are you agree? That is what we started with, right?
Yes.
So
Yes, sir.
yeah, so can you come to the specific reasons where you want machines to replace by humans? So that is what my next slide is talking about, and let us try to understand it fundamentally. We will not find this in any literature. So try to understand when we want computers to learn. Okay, so the first point, when it is very expensive to program using existing methods, then we want all are requested to mute. Then in that situation we want machines to learn. Like simple example, I have given you example of spam and non-spam email filtration, where human cannot sit and keep on doing that. So in that case, I have to write a program which is proactive. I have to write a program which is self-driven, and then I will have to do that task. Another example, like suppose, let me give you a very simple example. Suppose you have a data of 10 employees where they have their experience and they have their salary. Okay, try to understand very carefully. I have data of 10 employees where they have their experience and they have their salary is also there on the another axis, and now then I have to calculate out the best fit. Then it is fine, it is easy for me because the number of data samples are 10 only. Are you getting? Okay, but now when this number of samples will go beyond certain limit, then yes, existing programming methods will not be sufficient. Are you agree? Second point, there are some areas where human cannot reach, like navigating on the Mars. I hope then what we have to send programmed machine to take out pictures there. I hope I can give you some example of the movie Uri. What can you tell me? What was there? Something similar to this? There was a to take out the pictures from that area of terrorist. The Garud was programmed. I hope it can be drone. Yes, so Garud. I hope you are able to recall Uri. Okay, so Garud was programmed. Why Garud was programmed? Because human cannot reach there. There are some areas where humans are unable to explain their expertise, like speech processing, speech recognition, and there are some another applications where everything is dynamic, solution is changing with time, and then my traditional programming based on if then else does not work. Are you getting? So in this kind of situation, I have to think of replacing human by machines or computers. Is it clear? I hope you all are agree with me so far. Fine. So that's the reason we are trying to get into this very interesting area of learning. I am not talking about machine learning or deep learning. I'm just talking about learning, because after deep learning there can be something deep learning. We don't know. Okay, after 4-5 years there can be deep rest to 5 learning. We don't know. Example I am giving you. Now cognitive computing is coming up. Is it clear? So when you want to write small application of any learning method, always input is data. So try to understand data is the only oil today for any of the learning application, for any of the machine learning application, or for any of the deep learning applications. Is it fine? Okay, so there is one question: how can maximize classroom management and interaction offline and online classroom where a human fails or facing accurate measures? Yes, so that is another area which is coming up, and basically it's a part of managing your all populations in the class with respect to behavioral analysis. Okay, so that is another area which is coming up, and I will talk about it in the coming slides. Is it fine? So now before we go ahead, let me play a small video, and please acknowledge whether my video is visible or not. My video is visible?
Yes.
Okay, so it's a short video for 2-3 minutes, and I'm sure you will enjoy. So please watch it carefully. If you are not able to hear voice, doesn't matter, just read everything. And I hope your voice is visible, audible, sorry. So this is now coming up, narrow AI. Okay, I don't know how many of you heard about it, but in my next book titled, Data Science for Engineering Problem Solving, which will be published by Springer, I have addressed this narrow AI, and another AI is coming up now, trustworthy AI. So just for your information, because my objective is to let you know what is the future for next 1 decade. Okay, so narrow AI, explainable AI, and trustworthy AI. These three are going to be the buzzword for next 1 decade. Okay, so I hope you enjoyed this video. Yes or no? And the objective of this video is to let you know what is next. Okay, so let's move ahead with this idea in the mind, that what we are looking forward for next 1 decade in the essentially in the Indian context. So what is basically learning? So you can see here, when we want machines to humans to replace by machine, we want machines to perform these 6 important tasks. Maybe one of them, maybe two of them, maybe all 6 at a time. Okay. So what are these tasks are like? Decide, learn, predict, remember, analyze, and recognize. So there has been a lot of debate, maybe 2 to 3 years back, when I was there in the Europe, when I was attending one symposium of all data science industries and some universities, that what will happen if we'll start replacing human by machine. What about the employability of humans? But you can see here, there is no replacement for human, because humans are only there to program the machines. Is it clear? So I hope it is visible from the slide. So what we are expecting machine to perform these few specific tasks when you want them to learn. Okay. So this is another interesting slide from the presentation about what is going wrong across the world nowadays. You all will agree that when you do research, when you work in the machine learning or deep learning area, if you are teachers, you are researcher, if you are guiding the students, always what they do, students, they take up data set, they take algorithms, they apply that algorithm on the data set, and then finally they build a confusion matrix. So inside a machine, what is there? It is at this point, there is an input. I will not talk about supervised, unsupervised, already and you have been discussing it in the FDP. Okay, so there is an input, maybe data or past experience, and then there is output, and output is this 6 tasks. So what is happening today in the world, that people are not thinking about how this machine learning algorithm works. They are really not trying to understand how this machine learning algorithm works mathematically, and they just believe in giving some input, getting some output, and then building that confusion matrix. I hope you all are agree, yes or no? Let me see you are agree with me or not.
Yes, sir.
Right, so that is what is the entire trend is going on, but that is not expected. What is expected, when you use some machine learning algorithm or deep learning algorithm, please try to understand that algorithm mathematically on paper first, because that is what is the main objective, and then next objective is to build something on the top of it. But unfortunately it is going in the wrong direction, believe me. So, please, when you are using any machine learning algorithm or deep learning algorithm or whatever, just first try to understand how it works. Very simple question. Suppose I will ask you that, can you explain a basic machine learning algorithm of linear regression? Then I'm sure that many of the people, those even they have implemented it, are not able to answer how it works. Okay, and then if you don't know how it works on paper, and then how it is implemented in Python, and then how it is giving you output, then how will you think beyond it? Out of box thinking will come only when you understand existing algorithm mathematically. Is it fine? So this is very, very important message from this slide. Is it fine? So now when I talk about this, the entire implementation, I request all the participants, those who are attending this, FDP on emerging trends in AI and ML. I know that AI and ML is, yes, it is really moving ahead, and I'm very happy to share, my own books. You can Google data science foundations of. Sorry, just I'm texting some titles. Foundations of data science for healthcare IoT. Okay, if you Google this, you can see, or I can share the link with you. You can see here, google.com foundations of data science. Can you see my Explorer where I am browsing?
Yes, sir.
Yes or no? Yes.
Yes.
So you can see here, this is one of the book which is already published by Springer in last year, 2020. Foundations of Data Science based in healthcare Internet of Things. So I'm again copying this text, in the chat box. So the objective is, this is my book, which is doing very good. Another very interesting book, data analytics for COVID-19 case study. Can you see this slide? This is my another book, data analytics for COVID-19 pandemics, a COVID-19 case study. Okay, so I'm also texting this link in the chat box, and I'm happy to share this book. This book has got 2 awards in the year 2020. 2 awards are best outgoing book of 2020 in science, technology, engineering, and management. And another award for the same book is what best book in the focus series by CRC Press, Taylor and Francis. So why I'm sharing with you this book is not objective, is to just, objective is to let you know that what is expected when you are really working in this field. You have to come out of this, just taking a data set, applying algorithm and coming up with confusion matrix. You have to go beyond it. Okay, that is what I was sharing with you, that the next book which I am almost I will submit that book to the Springer next press next week, and title of the book is data science for engineering problem solving. So the philosophy is we are trying to cover all branches, even for civil engineering, for mechanical engineering, for chemical engineering, even for clinical or healthcare domain, how this data science will be applicable, so that that book will be useful to all branches of science and technology and engineering. Is it clear? Okay, so try to understand. I'm discussing this because my title is itself myths and reality. So what is going wrong is very, very important to understand. Is it fine? So let's go to next slide. You know which film, which movie it is? Come on. I hope you know this movie.
Yeah.
Uri.
Huh? No, 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 no. This movie which is there on the slide. Come
Robot.
on.
Robot.
Very good, very good. Okay, so just a few points to make you understand that this a machine learning and data science has also entered into an entertainment industry, and that is what is the very interesting statement is now this machine learning, AI, and data science has become an interdisciplinary emerging trend, not restricted only to computer and IT. Okay, so please try to understand. This AI was coined long back in 1956. Okay, but it was not so famous from 1956 till 2010. Okay, are you agree? Yes, AI was sometime elective. Are you getting? Yes or no? AI was sometime elective in many of the universities, but now this AI and machine learning and data science has become mandatory subject in engineering. Forget about that. People have AICT and UGC have started branch in AIDS. Are you agree? Yes or no? Okay. And even Mumbai University and Pune University, many colleges have started this branch of AI and DS. So what is the reason? So reason is only and only the next point on the slide. Why it is so famous today? So the reason is only and only data. That is what I have started with the same point. Data. Is it fine? Nobody has imagined that this data will go beyond the control, not to store, not in terms of storage and all these factors, but this data will go beyond to draw some meaningful insights, to draw some actual useful information from this big data. Is it clear? So that is the reason, and you should understand it. Why first? My philosophy is, whenever I deal with any topic, my philosophy is you should understand why, then you should understand what exactly it is, and then my request to you all to get into how it is. So why, what, and how should be the philosophy for you, even in the any of the FDP, even on the any of the workshop you attend, you attended, or you are going to attend in the next 1 year, or maybe any time, whenever, or hopefully we all are looking forward that it should be offline, so that offline discussion is always interesting than this online, but still this is a way out. Is it fine? So now, so data is the only, so data is the oil. Okay, data is the fuel. Data is the only business model for many of the companies. If I will ask you a very simple question, can you tell me what is the business model of Google? Have you thought sometime on this? That how Google is generating money? What is the business model of Google? You know that for every student, even of IIT, Google is a dream company. But then have you thought sometime back that how Google is generating money? Anyone? Why Google is not asking you to pay money, even they are giving you Gmail service free of cost? Anyone would like to speak for 1 minute? Come on.
So because it has huge number of advertisers, like on YouTube, on various web pages. This is
Yes.
how I think it generates revenue.
Yes. Okay. So data is the only business model. Okay. Data is a best business model for Google. They are using entire your data. Okay. So you can see here, there is a one interesting question on the chat box. What the analyzing all patterns. Yes, analyzing all patterns, and they are using the data for the same purpose, right? Can machine learning perform better decision making ability or able to enhance decision capacity of human being? How can use AI for behavior modification for human learning? Yes, that is the main purpose of artificial intelligence and machine learning. And machine learning is basically using past experience to perform better in the future. Okay, so that is how the model works for any machine learning algorithm. And yes, AI is very effective for behavior modification for human learning, and that is what is it has been trained, it has been used for the complete data set is used for training, and then the models are built, because model building is one of the very important step in entire machine learning. Is it fine? Okay, again it depends on the data set. I will talk about data set in the on the next slides. Is it fine? So now let's move ahead with a very interesting and important slide, that is, even title of the slide itself is biggest confusion, AI versus ML versus deep learning. Is it fine? So why title of this slide is like this, biggest confusion, what is AI, then what is machine learning, and then what is deep learning. So let us start our discussion, and let us try to understand fundamentally for what application you will call it as application of AI, for which application you will say that it is specific machine learning or specific deep learning. You can see the Venn diagram. This is a Venn diagram. What Venn diagram indicates? Machine learning is subset of artificial intelligence, whereas deep learning is subset of machine learning. So in turn, deep learning and machine learning both are subset of artificial intelligence. Is it fine? So this is how it is related, okay, logically. But when it comes to application, okay, no, it makes sense. So when it comes to application, why applications are very important? Because in industry, applied knowledge makes sense. Having knowledge is not important. You should be able to apply knowledge to solve real world problem is very, very important. And if you have problem in front of you and you don't know whether to solve that problem by machine learning or deep learning, then in my opinion, I would say your knowledge is of no use. Okay, so let me ask you a very simple question, that if I will ask you, and please be responsive, that robot, okay, self-driving cars, are these what are these examples? These are examples of AI or ML or only DL? Anyone? AI. Very good. Yes, yes. So robot, self-driving cars, these are all examples of AI, because it also includes machine learning as well as deep learning. Is it fine? Because that is a complete ecosystem, and you can look at the figure, Venn diagram. AI is a bigger picture. Is it fine? Now, very good. Mayank sir and Sam and Naina madam, absolutely correct. So now next question, be ready. Can you give me a specific example of machine learning? Can you give me a specific example of machine learning? Definitely it will be also an example of AI, but specific to ML. Anyone? Regression, Google search. Okay, very good. Regression, data prediction, absolutely correct. Absolutely correct. So when try to understand, when in nutshell, that is what a philosophy, and I'm here to share my own experiences and findings from my own learning. Okay, when you deal with the problem of clustering or classification, okay, that goes into specifically machine learning. Okay, yes, picture extraction. Okay, so when you go into basically Netflix, yes, Netflix is a recommender. Okay, so now Sam, I don't know Sam is sir or madam, but it's okay, Sam. Sam is sir or Sam is madam? Sam is responding on the chat box. So Sam is sir. Okay, so Sam sir, I have a question to you. So Netflix is using which machine learning algorithm? So that is very important. Netflix is using, yes, I'm agree. Netflix is an example of machine learning because it's a recommender system and we all are using Netflix, right? But now my next question is, don't worry if you don't know, absolutely there is no problem. We all are here to learn. So Netflix is using which algorithm from machine learning? Anyone? And this question is open to all. Anyone? So this is very, very important. Yes, anyone would like to answer? Voting? No. Okay. Unsupervised, yeah. But which, yeah, absolutely. But which algorithm from unsupervised category of ML? So it's using, yes, anyone? So this is required. Why I am asking this question to you? Because looking at the application, you should be in a position to answer that yes, this is an algorithm in the background. Okay, so it is k-means. Okay, it is k-means, and also it is based on KNN. Is it fine? So this is very, very important, and I'm very happy to hear responses from the audience. Very good. So try to understand. This is expected today. Application of knowledge means what is important is that application, looking at the application, you should be in a position to answer that this is an algorithm, this is a machine learning technique, and this is specific algorithm in the background. Is it fine? So now next, can you tell me a specific examples or applications of deep learning? Anyone? Come on. Any example which you came across, any example which you have read in the literature, which is specific to deep learning? Anyone? Please be responsive. Don't worry. Let it be wrong. Doesn't matter. We all are here to learn. Vision, computer vision. Okay. Umesh Chavan sir. Fine. Any other? Absolutely correct. Any other?
Face recognition systems.
Yes. Face recognition system. Yes. Very good. So now let us go fundamentally. When there is a problem of identification and detection, okay, that problem goes, yes, Sam sir, object identity. Yes, and that is what my objective is to and make you understand this entire topics fundamentally. So when there is a problem of identification and detection, then that problem goes into the category of deep learning. Is it fine? So object identity, computer vision, yes, these are some examples. But to above it, fundamentally, what is deep learning? When you have to perform tasks like identification or detection. Is it clear? So that is what is essentially the examples that will go into the area of deep learning. Is it fine? So now why again I'm it's very simple. I'm not posting these questions to criticize you. I'm posting these questions to make you understand fundamentally what is AI, what is ML, and what is DL. So definitely any example of DL will be also example of ML and AI, because it's you can see this they are subsets, but you should be able to draw clear-cut boundary between this AI, ML, and DL, and that is what is expected today. Is it fine? So now when we talk about this entire research of AI, ML, and data science, there are many interesting tasks which has been carried out by many projects across the globe. And my request to you all is that most of the time the philosophy is, unfortunately, that when you want to get into some new area, always we start digging out the research paper. Okay, but what is my suggestion to you all, if you want to learn something, please read projects first, research projects, using these emerging trends. Why research project? Because you will understand that how this project is as a bigger picture is implemented, and then you can come to specific research papers on Google Scholar or IEEE or whatever. So what is first important is my request, my suggestion to you all to read research projects first, because once you understood the project, how it has been applied there, then you understand the complete application of that, and then research paper will give you more minute details. I hope you all are agree with me, right? Looking at the product, and understanding the concept and then looking at the implementation is the next part, that is research paper. Are you agree with me? And do this practice sometime. I'm very sure that you will enjoy, because if you want to get into new topic, first try to learn. If you want to learn cognitive computing and this AI, I will suggest that, how many of you heard about IBM Watson? Yes, IBM Watson. Okay, so this is a very interesting and globally accepted tool by which company? IBM. Okay, and that will tell you that how this entire ecosystem works, and then you can go to the complete particular research component by referring to the research paper. So this is what I personally I would like to request you, and I would like to recommend you all. Is it fine? So now let us move gradually to the next part. You can see here, this is another very interesting trend which is going on. You can see that in 2010, data in GB was big data. Are you agree? In 2015, 17, yes, data in GB was big. But today, you know that even data in terabyte is not big. And I'm very sure that by 2025, data in zettabyte will not be also big. Are you agree with me on this front, on this slide? Yes, I will address this point, with AI and DS. Don't worry, books at the end of the session. Okay. Yes. So are you agree with me that the unit of big data is changing drastically, changing at very faster rate? Even now, you know that terabyte of data is not big, because we are carrying data in 2 TB 2 TB of hard disk or 4 TB of hard disk. Are you getting? Right? Even you know that nowadays we are using the laptop with 1 TB hard disk. Yes or no? Be responsive. Am I audible? No response in the. Am I audible? Yes or no?
Yes, sir.
Yes, sir.
Okay. Yes, sir. Very good. Okay. So this is another interesting point, which is transforming these trends in the technology. Okay, because the the unit of big data is changing at very faster rate. Is it fine? So now, so definitely when you are ready now to deal with this big data for drawing meaningful insights out of it. Okay, so what do we really require when you talk about this use of AI, ML, and deep learning in the future? So definitely, we require high-end, machine with good computational power. We also require large storage, and definitely we also require good support from the programming languages. And now, when you look at this slide is very important, because you know that the main objective is to deal with big data. So when your objective is to deal with big data, nowadays, every application of AI and machine learning, okay, needs to be integrated with cloud. This is a new trend which is coming up. Are you getting? Try to please listen me carefully. Every AI or machine learning application, if you are implementing, needs to be integrated with cloud. Is it clear? So that is what I would like to show you my next upcoming book, and you can see the title. The title of the book is, can you see what I'm browsing? The Convergence of IoT and Cloud for Smart Computing. Can you see here? This book will be there in the market maybe in 1 or 2 months. Can you see the title? Yes or no? Okay. So what is title is convergence of IoT and cloud for smart computing. Smart means that is what AI, ML, and deep learning. Is it fine? So nowadays this has become mandatory to integrate, and that is what the philosophy we have put in the next book. That book is going to be published by again CRC Press, that is Taylor and Francis. Okay, the book is already submitted, it is in press. Okay, so now please be careful that whenever you are developing any application in AI or ML, don't forget to integrate it with the cloud. And that is what these three, technical components are very, very important. When you want to get into this very interesting field of AI, ML and deep learning. That is fine. So we require high-end computing machines. We require very good storage, maybe cloud, and we also require good support from good support of programming language. Unfortunately, all which is the best programming language which is accepted globally is Python, because Python is coming up with rich set of libraries, and you need not worry about the implementation part to large extent, because it is supported by all libraries. And you just import the library, you import the data set, apply that algorithm from that library and get your work done, right? So that is what is how business in the, or rather IT industry works. So there is a difference. We are not IT people, we are researcher. We are working into this AIML field for doing our research, for doing our projects. So there is a difference, how industry works and how research in this field actually works. Okay, so what is AI? As the name suggests, you can see when you want machines to, or rather humans, your machines to mimic like a human brain, basically that entire process we call it as artificial intelligence. Is it fine? So there are lots of definitions in the literature available, and every definition will have different perspectives. Okay, but just fundamentally what is AI is when you want machine to behave, read the definition carefully, when you want machines to behave like a human brain, when you want machines to think like a human thought process, then that branch is basically go to the field of artificial intelligence. So this is something which I started with. Earlier there was a concept of automation using AI between 2000 to 2005 or 10. So objective was there is a mechanical operation on the shop floor, and then that mechanical operation was supposed to be automated, and all steps in the process were same. So program was written, okay, with the help of if then else, and then the entire mechanical process was used to be automated between that decade, where 2000 to 2010. So can you tell me, is it an example of machine learning? Anyone? Is there any learning here? Is there any learning? When you automate mechanical operation, it is not learning, it is just automation. Is it clear? Because it is written with if then else rules. Okay, so try to understand the difference. Learning is when, depending on the situation, you want machine to take decision. Learning is depending on the situation when you want machine to behave. That is basically an example of learning. This is an example of automation by writing if then else rules. Are you agree? All of you? Yes or no? Because we are automating the process, and automation is not machine learning. Is it clear? Please try to understand. Automation, digitization is not completely machine learning. Machine learning is when you are performing, when your machine is performing these 6 actions which I have shown you in my presentation. Is it fine? So all my friends, all dear teachers and all students, I don't know how many of you are teacher, how many of you are students, but yes, we have to be very careful. We have to keep ourselves updated. because you know all, particularly this teaching industry is not going through the good days. I hope you all are agree with me. And unfortunately, due to this COVID pandemic, the situation is getting again worse day by day. Are you agree? Teaching industry is really not going through the good phase. Is it clear? Okay. So definitely it is our responsibility now to make ourselves updated in this even pandemic situation and see that what can be done better in the coming days. Is it fine? Okay. So performing operation by using experience, and yes, but the machine learning, absolutely correct. But we'll see something beyond it in the next slide. So let's move ahead. So basically, this was an objective when I used to study artificial intelligence in my when I was student of engineering. Is it fine? So let's move ahead with this is something like Alexa. I would have shown to you. Alexa is there with me, and it's very interesting app. It's very interesting device, and they are assisting us on our all audio commands, right? So again, you can think about being an engineering individual, being a teacher in computer IT, NTC or ICT or any branch of engineering. We should not be interested in using the device. We should be more interested in thinking about what is there inside device, what is there in the background. If I will ask you a very simple question, that just think about how this Alexa has been programmed. So it's really imaginable, because we cannot think that how for every question it is giving you the right response. Are you getting? So this is something is required nowadays. And I will show you also one more video to make it more clear that what is the near future for essentially in Indian context. So rightly answered by Madhuri madam that practical knowledge is very, very absolutely practical knowledge is very important, because that is what is our responsibility. That is what is we are looking for. We want to, and we have to understand, and we have to implement, we have to prove that yes, how it works. Is it fine? So now let's move ahead. These are some examples like Apple Siri, Alexa, Google Home. So these are all examples of AI. Then the question is, next, AI bigger picture. Then subset of AI is machine learning. So when I talk about this subset of AI as machine learning, then again, you can see here, machine learning uses statistics. But then what is statistics? Machine learning is using statistics. You know that. All of you are agree? Yes or no? Okay. But what is statistics? Statistics is basically used to train complex models. And when it goes to performing or building a model like operational models of the brain, then that area goes into a deep learning. Is it fine? Then that suppose I will ask you a very simple question, that if how this linear regression works. So linear regression is fundamental algorithm of machine learning, but it uses statistics. Are you getting? Please listen me very carefully, but it uses statistics. So when I say that this is machine learning is using statistics, then if I will ask you a very simple question, then what is the difference between machine learning and statistics? Okay, can you answer this question, anyone? So don't worry, answer is there on the next slide. I'm going to explain you with the example, but first try to understand. Machine learning is using, because all machine learning algorithms are based on statistics, right? But there is a difference between machine learning and statistics. Is it fine? So let us try to understand first what is machine learning. On the next slide. So machine learning is a subset of AI, already we have seen, which uses statistics to enable machines to improve its experience. One of the participants have already responded in the chat box with this definition. So always, the input to machine learning algorithm is your data set along with the past history. And then, objective is to enhance the performance with experience of any process. Like Netflix is one of the example. Netflix is observing what you are watching in the past, and then based on that, Netflix is recommending you what you are supposed to watch in the future. Are you agree? So that is a recommender system. Is it fine? So now when we talk about these are some examples, and just think about how Netflix, that was my question was to one of the participant, that what is Netflix, which algorithm it is using, are you getting? Okay, so let us try to understand the next point. So this is one of the example of machine ML, linear regression, where objective is to find out the best fit. Definitely, I am very sure that you know how this linear regression works and how it is to be implemented, how it works on, you know, how it works mathematically on paper, how it calculates standard deviation, mean, and then, you know, how it is calculated with the SME. Okay, so sorry, MSE, mean square error, and then this is a mean square error, how it is minimizing the error, and then how you are finding the best fit. Okay, so this is how I'm requesting all participants to understand fundamentally every machine learning or deep learning algorithm. Okay, so now this slide is one of the most important slide from my entire presentation, and please listen me carefully. What is the difference between statistics and machine learning? Because this is missing in the literature, this is missing in the books, and you know, I tried to put this entire philosophy in the coming book I have already discussed. Okay, so look at this slide very carefully, and what this slide is talking about. In statistics, you formulate the problem, okay, and then try to understand. In statistics, you formulate the problem and then you generate data for this problem with the help of different statistical formulas. Okay, so what is happening in the statistics? The first step is problem formulation. Then once problem is formulated, you apply mathematical relations, mathematical equations to generate data. Is it fine? Whereas in machine learning, you know all, there is a data set. Okay, and then you post many questions on this data set to find out the solution. Is it clear? So try to understand. There is a very interesting difference between statistics and machine learning. And what that difference is: in statistics, we formulate a problem, and then based on the problem formulated, you apply mathematical relations from the statistics, and then data is generated, right? But
Hello,
in machine
good
learning,
afternoon, sir. 1 minute, sir.
Yeah.
I want to differ one difference that there is a statistics. There must be some error, a residual important. But machine learning, there is no error, minimize error, zero error. Is it different, sir?
Yeah, in machine learning, error is not zero. Error is always there. There is no any application of machine learning with zero error. That's the reason we never get 100% accuracy. Is it clear? Okay, fine. That's the reason we never get 100% accuracy. Always there is a error. Is it fine? But whereas in machine learning, we have a data set. Okay, please listen me carefully. We have a data set, and then we post some questions on this data set to find out the solution. Is it clear? So in machine learning, your solution is very expensive, data is cheap, right? Whereas in statistics, your data is expensive. You can see here, because we are producing data from statistics. Is it clear? Okay, and that's the reason whenever, so please try to understand fundamentally. I hope my discussion is clear to you all. What is exactly the difference between statistics and machine learning? Because in machine learning, data is not expensive, data is cheap. What is expensive? Solution, the questions you post on that data set. Okay, like questions to predict, to decide, to learn, to recommend, all these questions, right? Whereas in statistics, data is expensive. Is it clear? Because this problem formulated is not that much expensive. Try to understand. So this is a difference. Then many of the time, I don't know how many of you are really implemented machine learning algorithm, but model building is one of the very important step in every learning process. So this model building is one of the most important step, and it requires thorough knowledge of the data set as well as thorough knowledge of the underlying mathematical relations, so that it will be easy for you to build a model carefully. So statistic produces data and ML process the data and produce solutions. Absolutely correct. So that is what, absolutely. Yes, Mayank sir. Yes. So, it is what exactly what I mean to say, try to understand. Is it clear? And, I'm putting in another way, like in machine learning, data is cheap, but solution is expensive. Whereas in statistic, data is expensive than, your solution. Is it clear? Fine. So when you talk about, I don't know how many of you have built the, machine learning model, but modeling is very, very important. And that also depends on what kind of problem you deal with. Okay. So I don't know how many of you have heard about these three categories of the problem, that is descriptive, predictive, and prescriptive. But those who are working in this field should understand these three categories very carefully. And I will try to explain you with some examples here. Okay. So let us take a example that if you have a data set of the century scored by Virat Kohli these are types of analysis. But before that, let us talk about types of problem. And then you will understand the analysis carried out on this problem is that particular analysis. Is it fine? So let us try to understand the categories of the problem first. So descriptive analysis, predictive analysis, prescriptive analysis comes from that category of the problem. And let us try to understand the problem first, because problem category is also very, very important in model building. So let us consider that you have a data set of centuries scored by Virat Kohli from 2010 to 2020, for example. And now if I am interested to find out how many centuries are scored by Virat Kohli from 15 to 20, then this kind of problem will go into the category of descriptive problem, because you have data set and my objective is to find out number of centuries scored by Virat Kohli from 2015 to 20 with number of sixes more than 4. Is it clear? Okay. So now descriptive is type of information from the past. Yes, because we have data set and we are processing. So we are fine. So I'm giving you example. I'm not talking about the type of data set. I'm talking about type of problem. So what is my question on this data set? Data set is this analysis does not depend on data set. The analysis depend on what problem you solve. Is it fine? So my problem is to find out the number of centuries scored by Virat Kohli from 15 to 20 with number of 4 as more than 5, suppose, example. So this category of the problem will go into the descriptive type of problem, and the analysis is descriptive analysis. Now suppose you have same data set. I hope I'm audible. So you have same data set, and then my object is to find out how many centuries will be scored by Virat Kohli in next 2 years. So predictive problem. I'm performing prediction. Okay, so this category will go, this problem will go into the category of predictive problem, and analysis will go into the category of predictive analysis, that I'm predicting, I'm finding, I would like to predict how many centuries based on the data set you have, past experience. Okay, so based on the data set you have, you are deciding how many centuries Virat Kohli is likely to score in next 2 years. Is it fine? So this category is descriptive analysis. Okay, now last is prescriptive problem or prescriptive analysis. Suppose my predictive model is saying that in next 2 years Virat Kohli will score 15 centuries. Then what is prescriptive problem analysis or problem? That what can be done so that Virat Kohli will score more than 15 centuries in the next 2 years, because my predictive model has given answer 15. So what my predictive model has given answer, that Virat Kohli will score 15 centuries in next 2 years, depending on the data set available. So what is prescriptive problem? Prescriptive problem is what can be done so that Virat Kohli will score more than 15 centuries. So try to understand, business intelligence is the main objective of prescriptive problem, right? Another example I will give you from civil engineering. That is what, the philosophy we have put in our next book. So suppose philosophy is like, suppose the, we have the bridges data set of bridges, pool. त्याला आपण मराठीत पूल म्हणतो, ब्रिज, नदी के ब्रिज, नदीचे पूल. Suppose we have a data set of 200 bridges across Maharashtra. Okay, and now you can tell me what will be the descriptive problem if I want to find out how many bridge failure occurred from 15 to 20. So this will be a descriptive problem. If I want to find out how many failures are likely to occur in next 2 years, that will be predictive problem. Yes or no? Right? And suppose my prediction is saying that there will be five failures will occur in next 5 years, and then what can be done so that in next 5 years there will not be bridge failure, there will be zero failure. Is it fine? Okay, so this problem will go into the category of prescriptive problem. Okay, so if share market index is a prediction, share market index is a predictive problem. Okay, and what can be done to maintain or to improve the share index will go into the category of prescriptive problem. Is it clear? I hope both the examples are enough to make you understand what is this kind of, what are this kind of problem. Okay, yes or no? Yes. On farming with help of AI. Yes. AI in agriculture is very interesting area which is coming up, and there is lot of scope where we can apply artificial intelligence in agriculture. Okay, precision agriculture. There is another branch which is coming up. Precision agriculture is another branch which is coming up now, and it has a lot of scope in the Indian context. Is it fine? Okay, so like this there are many examples. Is it fine? So precision agriculture is one of the very interesting example, and I know I am working with one of the organization based in Kolhapur. Prescriptive means what can be done if the Virat Kohli will score more than 15 centuries. What can be done so that in next 5 years there will not be any bridge failure. Okay, so this is prescriptive problem. Okay, I can show you a syllabus which we have designed for all diploma agri people, and then they can join our certificate program where they can think of applying AI in agriculture. So there is a very small, very good organization based in Kolhapur, and we are mentoring that activity since last 1 year, and believe me, the response is very good, because they are really working on the field, and they are looking at how this AI can be applicable to agriculture or some other fields. Is it fine? So moving ahead, I hope this slide is clear, and I hope it was interesting to you all, difference between machine learning and statistics as well as different types of problems. Is it fine? So now moving ahead. So what is deep learning? That already we have discussed. When there is a problem of identification and detection, then we deal with, or we get into this very interesting field of deep learning. So it's like a rocket, but it is not like rocket science, but definitely it is with full of fuel. That is nothing but your data. So when data is more, we generally get into this deep learning, but again there are lots of misunderstandings about this deep learning. So let us try to understand what is deep learning first. Let me see what is there. Deep learning is so difficult, sir. It is not difficult, sir, at all. So let us try to understand. The difficulty is like people are taking it as a black box, and they don't understand what is happening internally. So when you understand what is happening internally, then definitely it will be more interesting. Is it not? Okay, so no one knows how it works so correct, because everybody is looking at it as a black box. So it is simple, you find out applications. Let me give you a very simple application. That suppose you have a class of 50 students, and you are asking all 50 students to write digit 9 on the page. Okay, and then you want to write a program to identify which digit written, what is the digit written. So this is an example of deep learning where, it's also an AI application with depth. Yes, but it is multi-layer learning. It is multi-level learning. Is it fine? And that is what many of the times people are doing mistake to understand what is deep learning. And unfortunately, the research in deep learning is going in the wrong direction, because that is what is next slide is talking about. Deep learning versus machine learning. This is a very interesting thought process, and again, I have put this thought process in my next book, that what is happening and what is requirement when you compare this deep learning and machine learning. Okay, so can you see when you look at this slide, it will be very clear to you that what is, or when you have to switch from machine learning to deep learning. But unfortunately, what is a trend today, even there is no need of deep learning, people are switching to deep learning without justifying, do you really require deep learning or not? Are you getting? Okay, so try to understand. Just look at this slide for 1 minute and tell me your observation from this slide. Come on. Look at this slide. I hope slide is visible.
Yes, sir.
Yes.
Yes, sir.
So look at this slide and tell me your observation. Come on, fast. What is the message from this slide? Yeah, more data can sometimes lesser the performance. Agree. So look at it very carefully. What I would like to, data goes on increase, then performance. Data goes on increase, then performance also increase. No. Okay, let's see. Yes. Okay, so you can see here, always if you are working in this field, and if your student or someone comes to you that, sir, I want, or madam, I want to work in this small amount of data, we can make better decision algorithm, not needed always. Okay, no, try to understand now. Listen me carefully. This is machine learning versus deep learning. Okay, and you know that deep learning is subset of machine learning. So without a reason, you should not switch from machine learning to deep learning. Okay, because nowadays, just in the afternoon, I was designing a syllabus for one of the university of deep learning, and then the first unit I introduced, that is machine learning to deep learning. So first unit, if you are designing a syllabus of deep learning, there should be first unit on this point, machine learning to deep learning. When and why you have to switch from machine learning to deep learning. Is it fine? So you can see here, you will find that with the increasing data size, machine learning algorithm will, this is a performance axis. Okay, so machine learning will start giving you good performance till some point, and after that point, machine learning algorithms will start performing constant. So what does it mean? Machine learning algorithms will not perform after certain size of the data. Are you getting, all of you? Yes. So performance is more deep with the less data. Okay, so you can see here. So this is a point where you will realize, so you can have very good paper on this. Try to understand if your student is, or you are working in this field and deep learning. So let us first try to convince yourself, your guide, journal, that you really require deep learning. Is it clear? So you can see here, when you start, so red line is machine learning and blue line is deep learning. It is written there. Older learning algorithm is machine learning algorithm. Okay, so the data size is increasing, and after certain size of the data, you will find that machine learning algorithms will start performing constant. Okay, so when machine learning algorithms will start performing constant, what does it mean? This is a point where machine learning algorithm will start underperforming, because they are not giving you better performance. So they are performing constant, or sometimes it can go down, or it will not go down, but at least it will perform, it will give you same results. So that is a point where you will have to switch from machine learning algorithm to deep learning algorithm. Is it clear? So there is a data dependency. There is lot of data dependency when you want to switch between machine learning to deep learning, and that is what is my request to you all, that please try to understand, convince yourself that what is to be done and when it is to be done and why you need to do. Because don't worry, don't forget deep learning algorithms. When you are using deep learning, whenever I'm working as a reviewer, I'm editor in chief, I'm co-editor for many journals in my area, and all journals are top 20 journals and transactions in the world in my domain. And whenever I get any research paper or PhD thesis in the area of deep learning, and deep learning algorithms are implemented on normal platform, it's of no use, because deep learning algorithms require high performance computing. That is what they are made for. Is it clear? That is what deep learning algorithms are made for. Deep learning algorithms are made for big data. You can see on this slide. You can see here, full of data. Fuel, where it is full of data. Is it clear? So now, and when you are implementing this deep learning algorithm, please ensure that your deep learning algorithms are implemented on high performance computing platform, that is GPU or CUDA. Okay, it requires high performance computing. It requires multi-core architecture. Is it fine? And if the results are there, I straight away reject the paper, or I straight away give my comments if it is a PhD thesis. Is it clear? Because deep learning algorithms are made for big data, very huge data, where you require high performance computing to process that data. Is it clear? Okay, so there is a data dependency, and this is a very important slide which will help you to understand that. Yes, and you can do some experimentation. You have to do some experimentation to switch from machine learning to deep learning. Then only it will be more convincing for you, as well as it will be also very convincing for reviewers. GPU and CUDA, please Google. These are high performance computing platform. Okay, graphics processing unit by NVIDIA, and you can Google also CUDA. These are high performance computing architectures which are made for high computational platforms. Okay, which are high computational platforms, and if you are using deep learning algorithms, they have to be implemented on this high computational platform, because they are not made to implement it on normal computing machine, which is i5 or i7. Is it clear, madam? I hope. Yeah, multi-core, not exactly parallel, because we don't have parallel processing with us, but multi-core, pipelining. So these are some platforms which will be helpful to you if you want to switch from machine learning to deep learning. So don't forget to implement them on GPU or CUDA, GPU cards by NVIDIA. Is it fine? So now let's move ahead with so this is something what deep learning is. One of the participants has said that deep learning is difficult. Yes, deep learning is not difficult, because we don't try to understand how it works. So that is the most important part. So first try to understand how it works, then only it will be more interesting to you. And definitely will enjoy working in this field, like feature engineering with input layer, and then hidden layers are there, and then there is finally output layer, right? But again, that there are three types of neural networks: ANN, CNN, and RNN. I hope you all knows what is ANN. Sorry, why I'm okay. So you know what is ANN. Yes, CNN and RNN. Is it clear? So ANN is artificial neural network, CNN is convolutional neural network, and RNN is recurrent neural network. But again, the philosophy is people or researchers don't try to understand when to use which neural network. Okay, so please try to understand when your data set is numeric. Okay, then it is recommended to use artificial neural network. when your data set is numeric in nature. Okay, when your data set is consisting of images and videos, then it is recommended to use convolutional neural network. Is it fine? And when your data set is time series data, like the data set of COVID pandemic for very short time. Let me give you a very simple example. COVID when started in India in Feb, and when people started doing experimentation in the April, the data set which was available was very time series data for short span. Do you understand? So when your data available to you is time series data available for very short span, then that kind to process that kind of data, recurrent neural networks are more useful as compared to ANN and CNN. Again, it is rarely given in the literature. So that's the reason I started this my philosophy of writing the book, so that at least readers, those who are in need of getting fundamental knowledge for any good topic, will understand fundamentally what is this INN, CNN and RNN is. Because I know when I started working in IoT in 2009, when I completed my PhD from Denmark, Europe, and when I was doing my PhD, believe me, there was no book on IoT. Only the source available to at that time was Google. And believe me, when I was reading Google for IoT, I knew all Google links which were there available because I read everything, but I could not able to get a good literature, and that's the reason I wrote my first book in this field of IoT. I can share this, and this book is doing very good. Internet. This is my one book available. I hope the link is visible to you. It is also there on Amazon. Yes, so this is a book which I wrote after my PhD in 2014. Okay, so this book is doing very good, and you can see I am the author, and this is the book on IoT and all these aspects, because it was really difficult at that time to get the good literature in that days. Okay, so let's move, and then maybe we can start with the question answer. So this is something very interesting images from the Europe, where we have intelligent transport system in place. What is ITS and use of AI and DL there? If you are standing on the bus stop, there will be a display that in next 2 minutes this bus is arriving, and in this bus there will be a display of entire sitting arrangement, and you can see that there are only 2 seats vacant. So this is intelligent traffic management, intelligent transport management. So these are all short-term applications in the Indian context. So we have a lot of opportunity basically to contribute in this area, but again it depends on how we explore ourselves, how we take maximum benefit of what we know. At the same time, it is also important to understand any topic fundamentally, because that is what is missing everywhere. Is it clear? So what is important is when you talk about this, these are all important topics. When you talk about machine learning, IoT, data science, so definitely now you can see that what is data science, because that is what is another interesting buzzword which is coming up now. So data science is something beyond AI, ML and DL. So don't worry, data science is basically a area which deals with prescriptive problem with an application of AI, as well as big data tools and techniques which are coming up in the market. Is it fine? So data science is same what we have been doing on data with the help of AI, ML, but along with that, we also have big data techniques and tools. Is it fine? So I think this is what something which is coming up now. So if you want to work in deep learning, you should know TensorFlow, all these mathematical operations, and the programming platform is very, very important. You must be compatible with Python, Anaconda, Eclipse. Deep learning 4J is coming now, IBM Watson, and I already told you that you have to integrate every AIML application with the cloud. So AWS is really coming with affordable cost, and I will request you to use this AWS because it is really affordable. So now this is something I wanted to share, but I will be very happy to answer your questions, so you can note down. I hope my slide is visible. Yes or no?
Yes, sir.
Yes, sir.
So you can note down my email ID, and if you have any doubt, any questions in the future, you feel free to write to me on my email ID. You can also note down my mobile number. This is WhatsApp number. You can put your queries in the chat box. Number is very easy: 9822 9822416316. So note down my number, and feel free to interact me anytime in the future if you want some guidance, some help, some support in anything in the areas like IoT, machine learning, data science, and so on. Once again, thank you to organizers. Thank you to ARMIET. Thank you to Naina madam, because since beginning she is coordinating with me with respect to scheduling and finalizing the topic and all. But I would be really happy if you have any questions. I will be happy to answer your questions in next 10-15 minutes, and then maybe we will conclude. So once again, thank you to all. Thank you to organizers. Thank you to ARMIET. I still remember the college is in the which one? Asangao, right? It is on
Yes.
that road. Yeah, but
Yes.
I visited your Thane office many times. Sir.
Gupta sir.
No.
Dr.
Amit sir.
Lavendra Botra, sir.
Botra sir, Amit sir, right? Amit sir is there. Sangvi.
Ankit Sangvi, sir. Ankit Sangvi.
Ankit Sangvi sir is there. So I have visited Thane office more than 5-6 times for conducting your MTech ME examinations, right? In the Thane, that real estate area office where you have office on the second floor, I think, right? The management office, right? Yes. So thank you very much once again to organizers, and I will be happy to answer your questions if any. Yes, over to you, madam.
Sir, actually the question is very simple, that how the faculty or any student should start learning the AI and ML, means from where they should start.
Very good.
That is the first question.
Yeah. So let me answer this question. If you want to really learn machine learning and deep learning, first complete a course of computational statistics, because that is the first point. And once you understand computational statistics properly, then get into fundamental machine learning course on any of the online platform, which includes your all basic supervised and unsupervised machine learning algorithms. Try to understand, try to relate it with statistics, and then next task is to go for deep learning. So this is the right way to understand this AI and ML. Don't forget to complete machine learning statistic course first, right?
Okay.
I hope your question is answered.
Yes, sir.
Yeah. Any other question? Which other question? Please ask question. Yes. No question. No question. No question means nothing is clear or everything is clear.
Hello, sir.
Yes, madam.
If there is a project of determination of soil pH, and we want to determine the soil pH with the moisture level and also with the nutrients,
Yes.
then what algorithm we should have to use from the machine learning?
Yeah, you can use machine learning algorithms from supervise, because you can label the types of soil you can process, and there are lots of project going in this area. Soil moisture prediction, prediction of pH values, and you can get, only the problem is you to get the data set. But to get the data set, you can contact to one of the agricultural university. You are from which place, madam?
From Sinhagad Institute, Pandharpur.
Sinhagad Institute, Pandharpur. Okay, so from Sinhagad Institute, Pandharpur means which is a close agricultural university to you. I think Pune only, right? So
Yes.
you have to contact to one of the agricultural university, because data set is the issue.
Yes, sir.
Yes, yes. Hmm?
हॅलो सर, तो जो डेटा सेट असणार आहे तो आपण
Hmm.
गव्हर्नमेंट लॅबोरेटरी कडून इश्यू करू शकतो का?
हो, मिळतो data set. They will give you data set. Don't worry, but you have to contact agriculture office.
येस सर. म्हणजे आता आपण जो सुपरवाइज लर्निंग वापरणार आहे त्याच्यात आपल्याला क्लासिफिकेशनचेच वेगवेगळे अल्गोरिदम्स वापरावे लागतील ना?
Right. But
पण
the
सर
problem.
प्रॉब्लेम हा आहे की मॉइश्चर लेवल डिटेक्ट करण्यासाठी म्हणजे सेपरेट वेगळं काही यूज करावं लागेल का त्याच्याच थ्रू
No.
होईल?
You can, that can be done, and then you can validate it with the on-field data. That is the right way.
येस सर. थँक्यू सर.
Yes. There are many topics in the precision agriculture, like optimizing the diseases. Leaf disease is one of the very threatening disease where farmers are getting affected a lot. So there are many examples in the precision agriculture, and particularly in the Indian context, there is a lot of scope. So I think you can plan to work in this area. I hope all questions are cleared. So if there are no questions, over to you, madam. Over to Naina, madam. Thank you very much.
One more question, sir. Actually, if we want to implement some sort of research lab in our colleges. Now, many of the Mumbai University colleges are going to start with AIML. But many times students or even sometimes faculty do not have the proper infrastructure to do the research work. So are there any facilities by the companies, organizations, or government use such details, because it will be really important?
Yes, if your college is accredited, then you can apply to RPS, Research Promotion Scheme of AICTE. That is one of the good scheme where they will give you good funding for setting up the small labs under your research. Okay, that is one way. Or that this machine learning does not go alone. You need some applications with machine learning and deep learning. So you can set up IoT machine learning lab jointly, where you can have IoT devices and then machine learning platforms, and then you can integrate them. Right, sir?
Beautiful explanation of all the topics, because from last 7 days we have learned different things, but now we have got the clear idea that what all things a new person or even the faculties and students should do. So thank you very much, ARMIET Institute, and we would like to listen more about the AIML and also for DM and all your research in future, because I don't think these 2 hours will be sufficient for us to the knowledge.
Yes.
Thank you very much.
Thank you all. Thank you, Naina madam. Take care. Bye, all of you.
Yes, sir.
Good
Thank you
evening,
so
sir.
much.
Thank you.
Hello, good evening, sir.
Good evening.
This is Vidyasagar. Is there opportunity for the game-based learning? How to imply the game-based learning in organizational management, sir? Educational system like online teaching, etc. And what are the future of this formulating the research? I want to do the research in higher education, sir.
Yeah, so to do higher research in higher education, the cognitive computing aspect, cognitive science is now really coming up. So you can go into it and you can read. It's really a very good area where you can apply cognitive computing to higher education. Right, sir? Yes. Okay, so thank you very much once again. Take care, all of you, and bye-bye.
Yeah.
Yes,
Thank you
shall
so
I?
much, sir.
Thank you, madam. Thank you.
Thank you, sir.
So now we have with us our next guest speaker, Mr. Anuruddha Tekade sir. He is a software engineer at Cloudian Inc. USA. He is working on edge machine learning with a tech stack of machine learning and Kubernetes. He has previously worked on the data pipeline systems that involve system design and development of use cases. Most welcome, sir.
Hey guys, thanks for inviting me. Let me start my video. Can all of you hear me okay?
Yes.
Yes, sir.
Okay. So give me a couple of minutes. Let me start my terminal. Okay, I think we can get started. It's almost morning for me, so I just got on my terminal and yeah, this is just the start.
Yeah, I know. It must be 6 o'clock right now.
Yeah. So hi, good morning, good evening, everyone. How is the session going so far?
Excellent.
Okay. So let me share my
I would
screen.
like to tell all the participants, Aniruddha is the youngest among all the speakers that we have attended till far, but we are just going to have lots of hands-on experience.
Okay, thanks, Vicky, for introducing me. So yeah, today's session is about machine learning infrastructure. So let me start with a very brief idea what we are going to look at in this session. So I'm trying to demonstrate how a machine learning application is deployed in the production system, which has a cluster of 3 nodes, which is a very minimal, uh, but this cluster is going to be a production alike cluster, which is actually used on a customer side. So let me get started. So what are the insights planned today? And yeah, one more thing is I may be uh, like running through the slides because I want to allocate more time to the actual hands-on demo. So the insights planned are like general idea is I'll be verbose about the concepts that what is machine learning infrastructure and what is not. Uh, then I want to also demo the work application I have chosen for today's session is something called as feature store, which is you can say a database for machine learning. And of course, this database is not a traditional database like we have in our traditional computer science systems that we have been studying. Then what is the concept of machine learning in a nutshell? How do we choose the technology stack to productize any particular idea? Let's just say uh, I want to do a spam filtration application, or it can be, for example, uh, the naming the images application, and depending checking on the live credit card transaction and detecting can this particular transaction be fraudulent. So why machine learning is basically taking entire globe on its shoulders is because not that it cannot be done in other computer science applications or technologies, but it has this power to notify the user much in advance, even before uh, that event is like, let's just say, happening right now. So you can actually notify the user much in advance that, okay, this particular transaction can be fraudulent, and based on that we can take the actions that are right to make that transaction secure and perfect. So next would be best resources to get started, the hands-on. For example, I'm an absolute newbie in the field. All I probably have is just know a very, very rudimentary level programming knowledge, such as in programming language C, or let's just say Python. Uh, the reason I'm specifying the languages is because nowadays, uh, like in practicality and also in academics, I believe most of the languages are trying to be similar. They are mostly trying to be functional. Of course, C being an exception there, because it has always like been with a requirement to deal with the systems on the hardware level, which is something others languages are not so great choice to be, you know, use as an alternative to programming. Then we'll be going for a live hands-on, and finally, I'll try to keep few minutes for Q&A. So let's get started. What is machine learning architecture concept? So majorly, it's a part of data engineering. Um, oh yeah, one more thing if I forgot to mention. If anyone has any issues or follow-up question, feel free to interrupt me in between. I think I would be more than happy to answer it as much as I can. So yeah, what is machine learning is, it's not basically something that we are focusing only on one application's successful run. It's an entire data pipeline. So let's just say you go to an Amazon.com and then you want to purchase probably a mobile phone or a book. So what you do is you uh, go into the search window and then you search for one particular product. And then, of course, being a user, we always have different choices in our results. So we at least navigate through multiple products and look at the current deals, or the different choices we have. And then we, let's just say, click on the first result. From the first result, we get few other links that, okay, these are the best alternatives, or the users who have seen this particular mobile phone also have been through these different products, or they have also seen this particular product. So now, being one particular X user visiting to one e-commerce website and then navigating to different pages, this is an actual lifetime event happening. Now, when user go through different web pages on that particular e-commerce, what it is actually when what actually user is doing is, it is generating an event, or rather we call it an event of streams. So uh, these particular events are collected in the form of metadata, and then they are ingested in one uh, end of the pipeline. This ingestion is basically just insertion of the data, uh, real time in real streaming applications such as Kafka probably. So data engineering starts at this particular point. And even before this, we need to make sure what are all different sources where can the pipeline be started, such as it can be a mobile application. And then even in, let's just talk about mobile application, we can have different um, uh, modes, such as we can have an Android mobile application. We have the Swift based iPhone applications, or there can be few others as well. So data engineering starts at, let's just say, part A, being data ingestion, where data is being inserted into the system. Then we do probably data filtering, data enhancement. We also make sure that there are no duplicate entries. So we also do the data deduplication. And then there is something called as extract, transform, and load, ETL. So this ETL process is bunch of part A submits to part B submits to part C kind of attachment, and that is how the entire pipeline forms. So this whole journey of data and the engineering we do for that is typically a practical concept of data engineering. um, Data engineering contains stages like ingestion, deduplication, like I said. Finally, we also store the data, and I must specify storing a data is a great deal, because when it comes to real-time fraud detection like use cases, so in these use cases, we need to make sure that our choice of storage should be first distributed, because that is going to be a real-time application. So we need to make sure that particular system of the storage is going to be tolerant over the network partition, because probably I am I am person doing a fraud or with an intention, probably looping over it. So I'm probably sitting in San Francisco, but I'm trying to um, scam, or you know steal data from the transaction uh, person sitting in some remote place. So even if the system is somewhere located in Europe, so even on the on network like over the network, I am able to perform all these operations. So that's one important aspect of it. Then real-time streaming is preferred, mostly using the systems like Kafka. So the important keyword here is the streaming, because there are tons of thousands of users who are basically performing the transaction. They are all generating the data, and this whole stream of data is being ingested into the same system. So it's not like just we have a bunch of 100 servers located at some data center, and then only those 100 servers are serving your entire system, because tomorrow there can be a big spike in the user data, user DAU we call it, which is the daily active users. And then your system should be able to handle that entire load. there are there is another approach of the DevOps and data scientist pipeline. So I believe from the previous sessions, you might have heard about the Jupyter pipelines. That this concept of Jupyter pipelines is a data scientist way of pipeline, but that is not something that can be productized, because and a practical machine learning application, if you take, and if you want to host it on the production system or on the customer site, which is typically referred as the on-prem, So a Jupyter based uh, data pipeline cannot be a practical application. So you have to go with the DevOps. So what I'm trying to say is you will be able to see that in the demo. Crucial parts to build pipeline is a strong automation. So that is probably what I mean by the DevOps. So development operations is something that basically uh, clubs and binds together the entire engineering for one particular application. Um, and yeah, when it comes to the edge machine learning, edge devices, for example, I want to work on the air detection systems where my sensors are on the very remote end, are like sensing the air particles and then giving me the data by extracting the multiple chemical components of it, and then I'm running the pipeline application in this particular domain. There are challenges such as edge devices usually have the least compute power, and then data is always generated on the remote end. So practically it is really difficult to take that huge amount of data, transfer over the network, and then process or do a data engineering on it. So like a best approach in these kind of scenarios is, instead of taking your data to the compute, I would say, why not let's take your like most efficient compute on a small scale and take that to the data and perform that on the edge device only. For example, you use your Android or iPhone based keyboard application, and if I'm typing some sentence, that nowadays keyboard automatically detects the next particular keyword which can be fit into that sentence you're typing. That is happening because there is always a small scale machine learning model that is running locally in your mobile application. But of course, a mobile application is not as powerful as an actual server that has the powerful capacity to perform different sorts of operations or machine learning. Does that make sense? Or am I going haywire? Are you guys able to connect with me?
Yes, yes.
Okay. So let's go with the next slide. So what is not machine learning infra is basically focusing on just one application, because mostly money is made of the idea of the machine learning application and not just one application. Because tomorrow, let's just say there's one button that's not working, it's not going to break my system. We need to make sure that entire system is stable. So for example, there is only one feature that is getting predicted. Tomorrow, my accuracy becomes wrong. That's okay. Rather than making sure that predicting accidental events, which usually takes an entire pipeline, is important. Like I said, Jupyter Notebook pipeline cannot be an infra structure for the machine learning. Singleton and standalone systems are not infrastructure, because when it comes to machine learning and we want to make money out of it. Tomorrow, let's just say some professor wants to um, take her idea and productize it and wants to make money. For example, I have seen in India we do not have like in a particular like shop, when you go and we say, okay, I want 200 gram chai patti. So 200 gram chai patti is an NLP based problem which a layman user cannot be, if um uh, like learned enough to use the terminal or keyboard kind of devices. So if we want to take it to the most practical level, we would probably use a speak and detect kind of feature. So in these kind of features, we we cannot have a standalone system, because that is never going to be productized to make it a making machine, which is usually a software's idea, because software does not have to worry about first we use a term called as MVP, minimum viable product. So this MVP thing always ignores how efficient your code is, how efficient, what is the choice of your programming language, etc. So these are some like hard realities of the world. um, System has to be always network partition tolerable over the network partitions, and best infrastructure for like as an example I want to quote are like Uber, Venmo, which is a payment system, or you might be familiar with Google Pay or GPay. There are different ad platforms which are always and always machine learning infrastructure. E-commerce manipulations that I referred or mentioned few minutes ago. So typically, based on your use case, your technology stack differs. So it, uh, let me start with the live production system. So if you have a b- an e-commerce website such as Amazon.com or Flipkart, so you need to have a strong streaming engine, which is Kafka. So um, Kafka is basically a distributed application where data it, is feed on one end, and then Kafka has this different receivers which have usually subscribed to one particular topic, and um, that topic is now uh, uh, based on the topic. There are different machines which have subscribed to it and which has data in it. So I'm just interested in the topic of mobile. So the mobile related data will be in one set of servers, and based on those data servers, I'll have next set of my pipeline which will be processing that particular data. So that is in like a Kafka streaming engine which is doing the job in real time. We need to have the huge compute and storage that can scale horizontally. So this point decides what kind of cloud operations or what kind of or how powerful machines should be. So typically, we cannot afford to have the on-prem systems in this domain. So usually we go for something as the public cloud machines. But there are choices in the industry, because I work for a company which has more than 600 customers. So we are not a typical service-based company. So in this particular thought process, customers do not want to, they are happy to use the AWS or GCP kind of cloud services, but with they're not happy using or keeping their data in a public cloud, even though the public cloud company or services providers such as AWS claim that it is going to be always secure and safe, because uh, multiple events have been in the history where data has not been safe. So uh, this choice, the second bullet, huge compute and data storage, is a debatable point. We need to have a live monitoring system such as Prometheus, and the graphing tool such as Grafana. Um, and when it comes to edge devices, so Kubernetes is a revolutionary technology nowadays. I would say Kubernetes is there in always all sorts of production systems, such as whether it is edge device machine learning, live production, or on-prem. So let me move to the next. Uh, Local training in the edge devices, third bullet is what I mentioned about the keyboard example. So when you're typing, or when you're using something, and if you type offensive, then you might have seen that when you say when you want to use any offensive word that's uh, in the knowledge section of the keyboard, it will not detect it, even if it is able to predict it. So there is always a small scale machine learning model that's always running. Typically, it's neural network and it's a very, very small scale. We need to also make sure that your model is not resource hungry. Otherwise, it will end up eating up your battery continuously. On-prem systems, what is on-prem is basically on premises. So let's just say I am a costheta.com company, and I probably deal with the online gifts merchandise. So I would never want to have my customers' data being shared in the cloud operations, public clouds. So I always want to keep the data on-prem. That's why all the object storage services like AWS S3, you might have heard. So they has to be on the premises or inside the building of the customer's office. And then most important factors, which are usually not core, but they do a huge impact, is we need to have very, very efficient system design. Choice of development language is extremely important, because C++ or Java uh, uh, can be too cumbersome to manage. Java, I would say, is like too verbose, and also it's resource hungry, because it has the concept of garbage collection and heap, which is not a great choice for edge device machine learning. So nowadays, the modern programming languages like Python or Rust are becoming a great choice, even Golang for that instance. And maintaining version should be easy. That's one. So let's start with the demo now. There are some preparation slides. How much time do we have? 6:40. So in India.
Yeah, no problem. You can.
Okay, so it's 17. Okay, so it's only 10 minutes so far. Okay, cool. Um, okay, so demo prep. We are going to discuss. Before we move ahead, anyone has any problems or questions regarding previous part of the demo, of the slides around data engineering or anything? Okay, good. So let's get started with the demo application. So the application I have chosen today is a feature store. Uh, what you're seeing here is exactly what the application is going to do. So we have streaming data. We ingest that from one end, and there is a batch data. Batch data is basically every 5 minutes you collect the data, you insert it into the pipeline, and that's it. So feature store is like a database, but it's not a traditional database system. It's a machine learning featured database which has different parts like monitoring, transformation, storage, serving, registry. And then uh, data scientist has a key role here, where choosing that, okay, hey, this is my model and I find this particular model as very efficient uh, choice of algorithm, and let's just use this to first train our data and then make predictions, or like machine learning use. So you train the model and then you use that trained model, for example a neural network, to serve your use case. Typically there are two choices of it: a nightly working, which is an like offline feature store, and an online feature store. So typically when you see that your traffic is down comparatively, you train your models, and then in the peak time you use that trained model to serve your use case. So I absolutely know that you might be feeling kind of disconnected right now, but soon, as I move to the next stage, you should be able to connect. So there are just like these concepts I want to explain so that we would be able to basically demo this particular part where I'm actually serving, and I'll show you how the code becoming the production into the system. So I'll be skipping few slides, just want to go with the concepts. So what is machine learning uh, feature store? It's a data used as an input signal to a predictive model. Input signal, um, for now, you can just consider this as a regular data input to the system. So for example, you are doing a credit card transaction, then it has a transaction ID. I'm referring to the table here. And then there is a feature called as like a feature refers to the entire column in the data set. So in foreign country is a feature, and then the value is boolean, false, true, true, and then size compared to the average transaction. So this is a feature value that's we are calculating, and then based on this we decide whether uh, uh, that particular value or that particular transaction can be fraud or not. But how do we perform this? So we need something called as feature store for this. So why feature store? Because consider a traditional database system um, that if you want to use for machine learning, what happens is your data is taken, then stored into the system, and then it is processed over. Feature store does not work like that. In feature store, you get the data, uh, you extract the features out of it, which is not actually the storage, and then those features are being transferred to the feature store, which is a Redis kind of application, which is we are just using locally to I would not say locally, which we are using in runtime to basically solve the purpose like transforms, store and serve, where we do not spend time in storing the data all the way to the database tables and then extract it. So feature store in ML application specific data systems runs data pipeline that transform raw data into feature values, stores and manages the feature data itself, um, serves feature data consistently. So feature engineering inputs to the model training, and model training again uh, 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 improves your feature engineering, which is like getting your predictions more and more accurate. Um, Next part is of course prediction, and then we monitor through tools like Prometheus or Grafana. I mean that's what the most popular I'm quoting. There can be multiple others. So data engineering, data scientists, or machine learning engineers, what do they do? This loop of this transaction that you are seeing, feature engineering to uh, uh, the model training evaluation, and then predictive services, which is part of production or the prod system that are running right now in your customers on-prem data centers. And then we have different machine learning elements monitoring elements where you can use any tool you want. But they all always refer to the feature store. So as you can see, typically in ETL process, what happens is part A transforms the data, part B stores it, and then part C loads the data out of the or from the database and then process it over. That's not happening here. This is all real time. So entire system would look like this, and feature storage is this one part. So when it comes to data pipeline in production or in real hands-on process, uh, we cannot have fixed A to Z, end-to-end system. So applications are are the ones who are producing raw data. So application can be Amazon application in your phone. Also have the streams, which are themselves being fed over the data generated by these different end users or applications, and they are also submitting the stream. We have different data lake warehouses such as Snowflake, AWS S3, Amazon Redshift, and there can be different. So at the bottommost part, it's mentioning ETL. So they are also the data sources being input into the feature store. So let me show you. I have been talking a lot and being verbose about what is feature store. So let me show you how feature store actually looks. So mm, so feature store is nothing but, this is a sample project I created for you. Jetty is my server. Uh, so you can focus on just this part. So I have different handlers, and feature store is one of the API. How does this work is, there are different features. For example, I want to put some records. So I have different APIs. Put record. Put record is basically put the record into the feature store. So it takes this feature group, for example, Netflix data. So Netflix data is nothing but uh, a CSV file, a very, very simple thing. Let me show you. Um, no, I don't want this there. So if I open terminal, oops, something is wrong. So let's go to the same directory. Um, okay, so as you're saying, this is a simple data file, a Netflix CSV, an actual file which has the column like show ID type. I can basically manipulate because we are not going to use this file locally because I have already kept this in my server. So show ID, type, title, director, cast, country, date added. These are the headers for my columns, and this is how a Netflix title CSV actually looks. That's it. So coming back to the HFS, what is going to be my feature group is probably features out of a Netflix transaction. So Redis is basically Java based Redis that we are using. Then we have the regular HTTP request and response. So like ignore all these details, but in a nutshell, you can at least read these three keywords: put record, get record, delete record. Simple. That's it. There are three basic APIs, and then we use the server feature store. But this is not something that I would go to run and like start the server and I'll use it. No, what we do is, because this is not how production system works, we use something called as containers. You might have heard about the Dockers. So what I have done is I have created Docker file out of it. So this Docker file, um, HSCR, HAPCR. Something is wrong with this. Hmm. Let me go with the basic. Um, so um, so what I have done is the HFS, our feature store. So this is a plugin. How this plugin actually works is it's a Docker file, and this Docker file is the one that is being converted into it. So Dockerized application is now we are going to run in the Kubernetes application, in the Kubernetes cluster. So the exact portion that we are going to run is we have the feature store serving. You have just seen a REST API, like put record, get record, and few others. So like you have seen feature group, we also have feature store, and it has its own APIs and different things. Then I have written a Python client, Python application. Like this. So this is a Python application that is actually exercising my API, and what it is doing is just using the Boto3. Boto3 is a like AWS client, but uh, just want to make sure we are not going to use AWS. I'm using just the library to connect to my cluster, which is same as AWS. So can I show you the cluster? Yes. K3s Kettle. If you have used Kubernetes ever, there is something called as kubectl. So this kubectl is basically a Kubernetes controller that basically controls your Kubernetes cluster manager. I don't use it in a conventional way. I have created an alias called K3s, because K3s is a Kubernetes tool. And it's a lightweight Kubernetes. So if you learn something from this demo today, probably this will be how Kubernetes is going to be used for machine learning, because you go to any single, you know, a real production system today, they're all talking about Kubernetes in machine learning, because Kubernetes is something that makes you machine independent. like literally in production. So even if you go to say Google Cloud, Kubernetes, then even they have different setups, and all the services are being provided. So that's what it is. I mean, every single person is talking about the best machine learning systems in the world: Facebook AI Research and Google Brain. Let's talk about Google Brain for a minute. So Google Brain has this ML infrastructure, and so AI platform. If you talk about this, what they are doing is they have different like systems which in turn uses so for example, let's say BigQuery ML. So how does this whole thing work is, so what I'm trying to explain here is, this is one entire machine learning system which has different sorts of like solutions or products. Now how does this work in reality is, we go to Google Cloud. Of course, we are not going to use this, but I just want to show how this whole thing works. Let me use my student account. Compute engine. Okay, so let's start with AI platform. So this is one of the product of Google Cloud Platform. Now I want to create uh, a machine learning pipeline. So go to pipeline, and then here probably you would create a new instance. Oops. Oh yeah, let me. So Kubeflow pipeline. What is Kubeflow? Kubeflow is basically, uh, as you can see, an open font size is too small. Open source platform for running, monitoring, auditing, managing machine learning pipelines on Kubernetes. My point is, everyone talks about Kubernetes today because they all want to be machine independent. So I hope I convinced all of you there a bit, at least. So coming back to our demo. So yeah, we are going to use K3s. And the reason I switched all the way to K3s is, instead of using kubectl, which is a traditional Kubernetes controller, I'm using K3s Kettle. So this is something I have generated. How? So I have a mapping for K3s Kettle. I have set up an alias for that. And then you can see here, it's nothing but kubectl only. Okay, but what I do is, I have created an alias K3s Kettle, and it's a typical kube configuration. But what it is doing is, it is referring to the K3s config. What is K3s config? So that is something which is located in my cube directory. So let's take a look at the cube directory quickly. This is one of my cluster which I use. This is what I have created for the demo today. So story in a nutshell is we are going to refer the server that is hosted at this. Uh, is anyone have like like, are you guys having any questions or like issues connecting to my talk? Uh,
No.
okay, let's continue. So K3s Kettle is going to use this this particular server. So what is K3s Kettle get nodes? How many nodes do I have in my servers? So ideally three, because those many I have created. Oh wait, I'm not over the VPN. One second. Okay. So if you do wide, if font is not too small, then you should be able to see these are the internal IPs I'm using. And the version of Kubernetes that I have created this cluster is running with version 1.20, which is almost like most recently released one by K3s. These are my system names, just like you are seeing SVKLN here, and I'm the user. That's what it is. And the base OS image is Ubuntu 20.04. Ubuntu is something I have started using recently. So far, I was a CentOS user when it comes to like machine learning pipelines. Okay, so um, moving to the next part now, like I mentioned, that we have the feature store and we have the other application, which is a simple Python script. And let's see how the whole thing works. So last night, before preparing for the demo, I actually ran through the whole thing and make sure that um, everything gets created just to. So let me delete everything first. Delete namespace app, and similarly I will you must be wondering, I'm running commands locally. There is no way I have you know you are able to see that um, how me running commands locally deleting the clusters. So that's what the story of K3s Kettle. K3s Kettle actually has the details to connect to the cluster. So now if we see, we still have HAP that just got terminated, so HAP should be gone. Cloudian should be gone soon. Usually I don't delete the namespaces, but right now we are going to start from the scratch. So as you can see, that was actually created 11 days ago. And usually I don't prefer to delete namespaces because that is going to wipe out everything. demos are usually bit slow than the general talk, because when things get hands-on, you never know what can go wrong, and you have to be always prepared. Okay, to deal with those things. Um, okay, I'll take couple of minutes to explain next part of slide maybe. So what we are going to say is create a cluster, which is uh, like already done. So create a cluster it's very simple thing. Let me show you on GCP how do we create a cluster. So how do we create a cluster? So I have a script. Okay, thanks guys. So oh, it was GCP. Come on, 1 second. No. Create cluster. Where is my script? Okay. Create cluster sh. Okay. So yeah, that's my script. So nothing too fancy. It's the basic shell script. I'm just referring a variable. Let's call it the test kubeflow pipeline. Okay, cluster. And then I'm using the zone US Central because that's what closest to me. I can use West, but typically most data centers are located in the central part of the US. And then I use the gcloud command and the zone value, of course this, and it uses the cluster name. It mentions that, okay, where this cluster need to be created, what version I need to use. I'm going with this most stable version that is supported by Google Cloud Platform. Let's see how does this work. So this cluster, create cluster, where am I located? Oh, ML infra demo. Okay. Okay, so I have oops, cd ML infra demo. So I have two scripts here. As you saw that we created, I changed the name because I already had that existing cluster. So let me run this. This will take about 3 minutes because Kubernetes cluster is not something, just like that. I am absolutely aware that most of you would be feeling kind of disconnected right now because um, probably the work I'm demoing is actually how things are being productized in the industry, which um, we are usually not that much into the academics. But I believe, guys, this is the right time when having AI and machine learning on the level that we can get the things operated over just few terminal commands and start productizing your ideas. So meanwhile, this whole thing, takes the create cluster operation works. If you have any question, feel free to interrupt me, like right now. Okay, there we go. The Cloudian is deleted. Now if we do K3S, it'll get NS. NS is basically namespaces. It's going out of screen for you. K3S, it'll get namespaces. So now you can see initially we had like two namespaces. Now there are only default cube system, cube public, and cube node. These they are the default namespaces that Kubernetes cluster uses. So K3s get nodes is basically three nodes you have. They are all ready. Which one is master? 202. And now, first thing, let me connect you through my slides. So what we are going to demo today is create a cluster, which I am already showing you on the GCP platform. Taking a small deviation here, if we want to create, let's just say you do not want to pay for Google Cloud Platform, Google Cloud Services, take 3 machines, regular 3 servers. And this is honestly because me myself, I'm a big fan of open source. I do not want to pay for proprietary service providers such as Google or AWS, because from outside it all seems fancy, but when it comes to managing all the resources, it's always great to have your own machines. So let's just say you have 3 basic computers and you want to create your own Kubernetes cluster. And again, keep in mind that we are actually moving only towards machine learning pipeline. I'll try to make sure I'm not deviating from my thought, which usually happens because on hands-on operations things take different turns. Yeah. Um, hey, anyone has any questions? Okay, I thought that was by accident. Okay, so take 3 computers. First step I'm referring, and go to, like, it won't take this long at it's saying, run this command. And then if you have, let's just say, 3 Linux machines, obviously these kind of things do not work directly on Windows, because when it comes to open source, 99% of the time you will find people prefer Linux or Unix operating system. So it's very straightforward. You can just go to a rancher, which is K3s, and then there is this quick start guide. Follow the instructions. It's the install script. That's how I have done it. K3s agent install script basically helps you. So like, considering the time constraints, I'm avoiding this. But yeah, this is how I have created this cluster we are using right now. Otherwise, you can always go with the public cloud services. So create cluster, then create namespaces for running the project. So let me create the namespace. Now that we have wiped out everything, one second, if there is any, if there is anything left, I have this P3s, delete forcefully, have all. If there are any leftovers, I just want to make sure that I'm deleting the machine. Okay, deleted, and also HSC all. Okay, so first thing, let's create a namespace. H3S kettle create NS. I'll create two namespaces, HAP and Cloudian. So now, if you do okay, this is still running. Something is wrong with the terminal. Anyways, we'll see that soon. So let's continue. So now if you do K3S kettle get NS, now you can see 40 and 44 seconds ago, both the namespaces are created. Hmm. Okay. The first thing I would do is um, I've created few things, but such as you can forget about it about the rest of the files, but this is hfs.py. That is my Python application, and I have a Kubernetes operator that is going to run this pipeline. So um, after creating the namespace, next is we need to dockerize the project with the Redis storage. So now um, take a look at this Docker file. What I'm doing is mm, I have the Python base image where basically I'm just taking basic Python library. Um I create, oh yeah, so every Docker image is a small scale Unix only, but it's not something heavily loaded. It's only operation specific. Then I'm copying the hsc.py with a name hsc.py in the Docker image, hfs.py as hfs.py in the Docker image. I'm also copying other images such as image one, image two, something like this. Okay. And then I install few packages. So that's why I'm saying pip3. Pip3 is basically being available from this Python library. And then I have added some dummy keys. They are temporary variables. You can ignore them for now. And then basic command is going to be Python 3. So I'll be actually getting into the pod and then show you how it is done. So now let's apply the resources. Is everyone okay with the font size? Because for me, it's too large. Okay. Now that we created, I'm taking a small like deviation here. So test APF cluster. So let's see if we have two clusters ready in our GCP. Um, just wanted to make sure that we finish this part, create cluster. So go to the compute engine. And you should be able to see the GK test KPF cluster default, right? So this has got created recently. Initially, I had my KPF. So test KPF cluster default. So that's it. Now basically you can connect it to the console, but again this is all cubesum process. So I always prefer to what I showed you earlier, keep my config file in the um, cube like this, and then this will actually help you to connect to the cluster. So similarly I have all different files here, right? So let's continue with our K3s only. That's it. Okay. So we created the namespace. Now let's move ahead and create my operator. So what I do is K3 settle lie minus f hap all. So what is hap all? Um, so again, this is something that is going to basically hold my cluster. So I specify that, okay, hey, this is going to be my cluster. These are all different YAML. You don't have to worry about all these details, because eventually when you get started, eventually we'll come to this. There are different SDKs that you use to generate all these files. But of course, it's not as straightforward usually as we see, because when we actually get started with the things, they will take time. For now, just consider this as if it's like a main captain of the team who is responsible for everything. So as soon as we do this, what you should be able to see is there is K3s kettle get pods in one of the namespace that we created. So have operator. It has been created hardly 68 seconds ago and it's running. So operator is like a pod in Kubernetes. What is a pod? Pod is a very small scale data unit or compute unit or element of the Kubernetes cluster that is going to run your machine learning application. Again, I want to like rephrase the same thing. When we are talking about machine learning infra, it's not the machine learning application we are talking about. It's how that application is deployed in the system and used in the production. So, um, um, okay, let me take it to the other window. So once the operator is created, now there are different resources. So you can see there is a pattern: pre-resource YAML and post-resource YAML and main resource YAML. So post-resource is, so what is pre and post? If you take a look at the file, pre-resource are something that are the precondition. I mean, it is important that they all need to have um, Thank you guys. I am really happy you are liking it. Although I'm absolutely worried about whether I'm able to, connect myself with all of you or not. Okay. So um pre-resource is something that is basically useful for running an application. So for example, I have a part of a pipeline, let's just say HFS, and HFS needs one set of resources. Then we specify those resources there. Let's peek into the file. HFS pre-resource. Actually, I can show you here. Otherwise, I'll keep switching between the windows. So as you can see, all I'm doing is I created something called as config map. What is that? Don't worry about it. Let's focus on the data part of it, which is an YAML. So I am creating a service called HFS, which is which should go inside the namespace Cloudian. That's why I created this. And then it refers to one particular image. So where do I specify that image? So the cluster IP cloudian.com, and the pre-resource, and there is now a main resource. So where do I specify that image? In the main resource, it creates something called as stateful set. Stateful set of resources. Consider that for now. So it has specifications, and then it refers to one of the image. So this is a public image that I'm using. And Vijay is my colleague who hosts the image there, like I have done for the other part. So let me show you what exactly I'm talking about. And so this particular image is accessible only to the subscribed customers, but with like it's public for me, not outside the organization. So let me show you. Have you guys heard of Docker registry? So there is something called as Docker Hub. And here, these are all different images that I use. Most of them are public, but they are specific to my usage. So, and Vijaya, I guess HFS. So these are different images. My colleague is hosting, and this is what we are going to use in our uh, demo today. So this is one image. There is also another image which is on different Docker Hub. We call it as um, oh, I'm not able to recollect the name right now. Let's come back to this later. But yeah, for now you can consider this. So we are going to refer this image. Yeah, I remember. So it's quay.io. Um, quay.io. Again, this is like one of the open source thing, but now I guess recently Red Hat purchased this thing. So these are all different sorts of images. Most of my images are hosted on that, but what we are going to use is the HAP operator. So if you look at the tags, So here, that is how you can pull that image, quay.io. So am I talking truth? So yes. How can one uh, verify that? So you can take a look at have all, and maybe we can grep for um, probably image, and then you should be able to see quay.io HAP operator. So this is exactly the image that we are using from here. Tag is basically a build. So for example, latest is a tag. In my personal content, there can be, oops, my profile. There can be tags. So let me see. Which one can I show you? For example, Spark tags. So I have pushed this particular tag multiple times. For example, Spark 2.4.5 was one of the version I have worked on. Or this is just a tag. I mean, that doesn't basically change anything, provided that you're just pulling the build image. Okay, so coming back all the way to our thing. So now the pre-resource is something that you actually require to run your application. Main resource is what you have seen, that okay, this is my image, um, how many nodes I'm going to use. So let me demo. Let me share HFS, maybe HFS main resource. Oops. So here you can see that okay, how many replicas do I need? So I say only one replica of labels. These are all metadata. You don't have to worry about. I'll be referring to this particular application as HFS, which is Hyperstore Feature Store. Hyperstore is nothing but the object storage that I'm going to use. And then this is my image, how many volume mounts, HFS data, and etc. Oh yeah. So there is the Redis container. This is a public image, by the way. I must specify. And so one image is the feature store and the other is Redis. We are going to use both of them in the same container. So pod is basically a giant machine or basic unit of Kubernetes. Pod contains multiple containers. So one container can be created with more than two images of Docker. So the whole story of my entire talk is, you can take any damn application and you can convert that into a Dockerized application. Why do we need Dockerize? Because there have been traditional systems such as VMware uh, who used to consider themselves, leaders in the virtualization, and then all of a sudden, Kubernetes project start coming up from Google, and they open sourced it. As soon as they open sourced it, Kubernetes community grew like anything. So Kubernetes community has like thousands of users. For example, even if you just go to now they are like, they are actually revolutionizing the entire industry. So because you do not have to be dependent on one machine, all you need is even a single server or single machine, build a Kubernetes cluster, and there you go. You can just go on deploying any single concept that you have in your mind. You convert that into a piece of code, such as, let's just say, a very small scale Python script, and that's it. It becomes an application serving probably tons of customers, which means an half hour of coding work can actually start generating around, say, 500 rupees um, per day for you, thanks to Kubernetes, because you all you need is one computer and then you can productionize it. So um, back to the, okay. So let's apply. We created namespace, we created the operator. Now next part is, let's apply the operator, the resource YAMLs. So I will say kubectl. Oh yeah. So k3sctl get pods. Let's start. This is a great time we can start watching the namespaces. I'll keep watching it. Now I've enabled the W flag. And similarly, let's keep watching the other namespace, Cloudian, which actually do not have anything in it. Okay. So now let's apply HFS pre-resource YAML. I'll only apply the pre and main for now. I'll go ahead with the demo just in case you anyone feel to ask question that, okay, hey, Aniruddha, why have you applied this particular file? Just feel free to interrupt me. I'll be more than happy to answer in my own capacity. Like I mentioned, we are going to use 3 applications: HFS demo 1, which is my Python script, and HSC is just other sample application, which actually refers to the edge you are seeing, the hyperstore. So that hyperstore is nothing but the hyperstore, which is HSC. C is container. So it's an on-prem S3 service, or on-prem S3 software that I have containerized. So we applied pre and main for HFS. I'll now apply k3sctl apply sf demo 1 the resource and demo 1 main resource. Okay, what impact does applying these 4 commands created? So now my HAP operator knows that, okay, I have 2 members, HFS and demo 1, because we have specified that in those YAML files, and it is now ready to use this. So if you look at the sequence, now we are I think I explained how we can dockerize the project by explaining the Docker file. Now we need to move to the next part, where we will be enabling each of the application one by one. So what do I mean by enabling each of the application? For Kubernetes, it has nothing to do with what kind of application it is dealing with. You only tell Kubernetes that, hey, these are my resources, this is my stateful set. I mean the set of resources. For example, I have requested 2 CPUs, 100 sorry, 200 CPUs and 100 gigabytes of RAM. Then Kubernetes is always ready to deal with that particular type of application. If you want to go with the small scale, that okay, 2 CPUs and only 2 gigabytes of RAM, then it should be happy with that application as well, because it doesn't take the responsibility of running that application, making the features of that application available. It takes the responsibility of running that application successfully, which now we are about to see. So cat cat app CRYAML. Okay, so now what I do is, we have this HAPCR. CR is like the custom definition. So custom definition is first introduced by HAP operator into the cluster. Now it knows that HAP operator, if you remember the file description that I showed you, HAP all, what I am doing, mentioned something called as HAP cluster, right? And this HAP all just introduce the custom resource definition, which means I created a custom resource. Tomorrow I can have a Python script, um, enable that it has capacity to enable, say, automatic image detection, um, and it is not a type of any programming element or any particular classified application, because tomorrow I can name it probably, say, the first name I'm seeing here is Mayank Mangal. So tomorrow probably I can say Mayank Mangal application, and then that is a custom resource. So Kubernetes do not worry about all those things. So I introduce the custom resource definition to it. Operator knows that. How? Because we have specified that, hey, this is going to be a kind HAP cluster. So now onwards, I introduce anything that is of type HAP cluster, please take care of it. So to validate this statement, please take care of it, what do we do is, we introduce a custom resource, cat, because we introduced the custom resource definition, CRD. Now we need to introduce the CR. So CR, and you don't need to worry about this. This is a dummy sign, because HAP CR is just is just a normal YAML. It is not going to be a pod. So let's apply this file first, which means I am introducing my plugin list. So k3s scuttle apply -f HAP CR YAML, and it will create the HAP pod. So HAP pod is basically the cluster pod, and it's running. So it's been 2 seconds, right? So now that we have introduced the plugin list, why not because still you're seeing the Cloudian namespace empty. Let's enable our first plugin, which is HFS, the main application we have been talking about so far. So what I will do is Sublime HAPCR. Okay, let me use Vim here in the terminal itself. HAPCR YAML. Okay, and I only change this from disable to enable. Okay. As soon as I do that, I reapply the file, and you should see that, okay, it's now configured. Initially, when I applied the file, it was created, and there we go. On this bottom right hand side, you can see there is a container being created, and that's it. It's running already. Okay, so one of the application is created. Can I disable that? Yes. Again, the same thing. You change that to disable and you should be good to go. Let's enable a demo one application, because the architecture I have created today to demonstrate is HFS is one part of the pipeline and demo is another part of the pipeline. HFS has all the REST APIs that is actually responsible for reading all the features, and demo one is actually exercising those features. How? So demo one has this Python script that I showed you, and demo one is making calls to a different system, altogether a different system. What do I mean by that is each pod in every namespace is a different Unix box. And the bigger picture, if you have lost the track so far, is we are not doing this locally. We have a 3-node cluster in the cloud. That 3-node cluster in the cloud is acting as a single unit, one of them being master. And I'm sending over my commands through K3s kettle to that master. And then uh, I'm using the Kubernetes environment. Feature store is my machine learning application. I'm exercising the machine learning application APIs through my demo one. So let's take a quick look at this. So focus on only this part, feature store. So of course, I cannot have like heavy systems like Kafka running on a 3-node cluster. That's why I'm showing only this feature store part. And specifically in the feature store, I have different REST APIs and I'm using Python SDK. The data set that we're using is already I have shown you the Netflix CSV, and uh, and it is the actual data set by Netflix. If you want to verify that I'm sharing the facts, I guess the best resources can be 538 538 538, sorry, 538 Netflix. 538, it is a public polling website where all sorts of data gets collected. So for example, um, the battle for Emmy nominations. Do we get any data here? Yes, because this is one of my favorite blogs that I always keep reading. Do you know what's going on in the data science field? Data. Oh, come on. Excluding Fox. Oh, wait. Let me show you something. Usually we always have it. Why the Republican Party? Okay. So usually data is located somewhere. 538 Netflix data. I'm not able to find the link here. 88%. Usually they all share their data. It's always publicly available. But anyways, let's not waste time here. You can reach me out on this part. I'm still wondering why there is no straight line, but that's okay. Okay. So coming back to our demo. So we have HFS. Let's enable our next plugin. The Vim AppCR YAML. So as soon as we do that, we reapply the file. It's configured again, and then there is another pod upcoming in the cloudy namespace, which is demo1. Oops, something is wrong. Okay, 3s little get this file or demo1 space cloudy. HFS config not found. Oh, okay. Let me check the config maps quickly, which is that I'll get CM cloudy. Okay. Config map demo one free resource. That should be fine. So it's saying so basically what's happening here is demo1 need to have the HFS config map as a volume, which it's not getting right now. But why? So okay. Created app operator. HFS pre-resource, main resource. I see. Okay. So if you remember, when we did enable the demo one, so here, once you enable the HFS application, you also need to basically enable the HFS post resource, because now application is running. So uh, we need to get the IP for the HFS. So let me do that. Get services minus Cloudian. So HFS got this API, which I need to update inside the demo1 demo1 configuration. So what I will do is now subl demo1 demo1 okay, subl demo1 main resource YAML, and then we have HFS post resource YAML. So HFS post resource has this old IP. I replace this. I replace this, which is an actual running IP. And now I apply this file. So the issue that you are seeing here should be resolved soon. So K3 settle apply HFS post resource. As soon as it is done, we should see a config map getting created in the Cloudian or HAP namespace. And operator will detect that change. Oops, sometimes it's slower, it seems. It's just it'll get pods. Let me re-enable the plugin quickly. appcr.yaml disable. I apply appcr. Now, so demo 1 is terminated. So K3 is settle apply appcr. Now that we changed it, okay, and we have it running. Probably it was stuck there. So okay, now that we have this running, let's get into the demo1 pod and see if we are able to exercise the application HFS. So K3s exec IT is basically the interactive mode of getting into the pod. Demo1 is my pod. Bash is basically the application, and the namespace I'm running is Cloudian, because that's where my pod is running. So let's get into it. Oh, that's wrong. Okay, So one more thing. So K3 scuttle get SVC. This IP is the IP of the pod for HFS, and then of course this is within the cluster. And now here I have all my data such as Docker file. I'm not sure if, yeah. So this is the same Docker file, guys, that I showed you. And as you can see, I created this pod in front of you. So, um, so the same exact file that it got where all the resources are there. And then it has this hfs.py, hsc.py. So let's get into the Python terminal. Sorry, not terminal, and Python exercise. So if we now do that, it should be able to connect. Okay, something is wrong again. So looks like it's not getting the connection. Let's check if the data we have in the HFS config map is correct. K3 schedule describe config map HFS. It's in HAP describe CM HFS. Config. Oh, something is wrong. Okay, schedule. Okay, let's start from K3 schedule get pods delete. Okay, wait. Let me disable both the plugins first quickly. Vim hapcr YAML. This cr.yaml. Okay. Okay, now that it is terminated, let's reapply HSQL all, which is unchanged. Okay. Then we do K3 schedule apply HFS pre resource YAML unchanged, HFS main resource YAML unchanged. And now I'll wind up the session very soon. It's just that I want to show how the application is going to talk with the actual ML part, because I know you guys might have been sitting all the way since the morning. So okay, demo one, the resource. Okay, so now when have CR YAML, and then I apply have CR. K3s get pods. Okay, so now we get the SVC for K3s get SVC for HAP for HFS cloud DM. Oops. So we take this, we add it into the HFS post resource. We apply the post resource. Configured. And ideally this should create a config map in Cloudian, which is causing the issue. So let me do a get config map CM into namespace, and there we go. Now we have HFS one. Something I messed up in the initial stages, guys. So now we come back to the HAPCR. Give me just 5 minutes. I'll wind up the session soon. And thank you all for your patience. So I'm enabling my second application. And here, now I do okay, 3 skittle apply F HAPCR. And the demo one should start running. Now I exit into this pod, so I'll use my terminal in this quadrant. So K3 is kettle So K3 is kettle exec this. Probably this will cause an issue. So let me move the namespace here because Kubernetes made some changes in their recent release. And now directly, if I run the hfs.py, it should be able to connect it, I hope. Oops. Okay, so something is wrong with my connection, I guess, but last night I recorded a video for you, which is a quick demo that I can, show. Just drive.google.
Welcome to the demo one of App Operator. We'll start the
skip to the
my cluster IP. Now the service should be.
This is actually a backup plan just in case, the actual system fails or something, because things happen. So
Up. And finally, delete.
Okay, so this is a part where I'm actually showing how this is run.
So let's execute hsc.py. As you can see, it failed to read HSC credential. And as you can see, the API calls to the HFS is successful. We have these APIs called in this script: create feature group, describe feature group, list feature group, then put record, get record, delete record, and finally delete feature group.
So so that's what the overall journey for the feature store is. Feature group is something we create features related to Netflix, then we put get delete record kind of operations we go through, and there can be like follow-ups that can be disable the applications. Yes, I think that's what I have seen, what I have shown you. Changes that we do gets automatically reflected on the cluster, and that is how basically you can um, um, you know you can maintain the run or lifetime of your application. There are best resources which I would suggest as a concluding part for my demo. So Coursera has this Professor Andrew Ng, who happened to be the pioneer of the Google Brain group. So Google Brain and Facebook AI Research, also known as FAIR, they are the best machine learning teams in the world. It's always great to follow their blogs. Deep learning specialization has around 5 courses. In their entire course. I wanted to talk more about this, but like considering the timeline, I'm concluding this. So blogs, Fair, Google Brain, they're absolutely fantastic to read. Towards data science is like a, a medium group which actually focuses on this part of the technology domain. Reddit has multiple subreddits where like machine learning stuff is a great to follow and take part in. Typically, if you want to like start making your projects turn into ideas and making money out of it, which literally anyone who has the basic knowledge of mathematics and has fingers and can type code should be able to do. I always say that. So scikit-learn, PyCharm, Python, and R. R is typically for I suggest only for the non computer science background people, because it's sort of more towards mathematics, and an algebraic base good enough till the class 10th mathematics or something. To practice machine learning stuff, Kaggle is the best resource. It's like the lead code or hacker rank of the machine learning. So you should definitely visit Kaggle, where there are always competitions uh, going on and there are prizes. So more than prize, I would say the great deal is companies reach out to you and offer the jobs. But of course, I believe most of here are the professors and assistant professors, associate professors, professors in this thing. But you can definitely suggest this thing to your students, and eventually, even if you don't win the competition, the um, uh, the resources over here will definitely help to get active in the job market, which because right now in India, typical approach is like we get our degrees and we always are looking forward and very being optimistic to the campus placements, but industry is going to more towards the, I mean, it prefers the candidates having good systems knowledge, such as the concept of AP and CP, where a system can either be availability and like availability tolerant and the part tolerant over network partition, such as Cassandra, and it can either be CP, which is it can either be consistent and tolerant over the network partition. So that is a basic knowledge of engineering, which is, I guess, which makes you an engineer productive, because having just data structure and programming won't help you to create the projects and productize them. You have got to know a very good system design, and you should also need to know how you can scale the resources, and obviously operating system knowledge, that like very good hands-on on Unix terminal is a great thing to have. So uh, that's pretty much everything from my side. If you want to reach out to me, I'm mostly very active on Twitter, but I follow people. I usually don't tweet anything unless someone reaches out to me. Otherwise, you can follow my blog at this. Um, so these are my GitHub IO pages, where I'm mostly active. And here, most of the links are provided, even my Stack Overflow and all the projects that I'm currently working on. So that's pretty much everything. Let me know if you have any questions regarding like things to do, not to do, what are the best practices and everything. Because it's really difficult to, you know, like include everything in a 1.5 hour session when it comes to data engineering or machine learning.
Sure, Aniruddha, I can understand this because practicals is not a simple uh,
I guess your voice is breaking, Vicky.
Vicky sir, your voice is breaking.
Yeah, your voice is breaking. Yeah.
So, like,
Naina ma'am, you can.
Nana ma'am, please continue and validate the session.
Okay. Thank you so much, sir, for today's session. It was very interactive and informative. As today is the last session of our program, so I would like to thank our chairman of ARMIET, Shri A.V. Gupta sir, director and founder trustee of ARMIET, Dr. L.S. Potra sir, in charge principal, Dr. S.M. Bryce sir, for giving us this opportunity to conduct this faculty development program. I would also like to thank our program's guest speakers, Mr. Suresh Shakkarwar sir, Professor Rahul Divte, Dr. Pallavi Chauhan, Professor Priya Latia, Mr. Arunjit Chaudhary, Mr. Cyrus Rantin, Mr. Vinay Purhade, Professor Om Prakash Yadav, Dr. Ramchandra Mangrurkar sir, Dr. Parikshit Mahalle sir, and Mr. Aniruddha Tekade sir. I would also like to thank our advisory committee, Professor Ankit Sangvi sir, HOD of Computer Engineering Department, Professor Mayank Mangal sir, HOD of IT Department, Professor Vivek Pandey sir, ME Coordinator, Professor Sheetal Agrawal sir, Training and Placement Officer. I would like to thank the Program Coordinator, Professor Vicky Patil and Professor Radhika Mundadame. I would also like to thank our Technical Coordinator, Professor Sonali Vidate ma'am, Professor Rajesh Botra, Professor Hina Patil, Professor Priya Dule, Professor Akash Patil, Professor Vandana Soni, Professor Abhilasha Bafna ma'am, Professor Shweta Shingar Putade, Professor Vella Durai sir, Professor Ranjit Chinugu sir, Professor Vaibhav Dhage sir, Professor Priyanka Sonone ma'am, Miss Tejaswani Farde, Miss Trupti Bombay, and Miss Bharti Jadhav, and all the participants for making this session very interactive and successful one. Thanks a lot once again, and take care, all of you.
Thank you, guys.
Thank you, ma'am. So your certificates will be provided within the 5 to 6 days. After analyzing all the attendance parts and feedback parts, we'll provide you certificate on your mail ID. And all the stuff regarding this FDP will send in the WhatsApp group that is created for this FDP. And as well as we will try to send on mails also. So thank you all of you for joining this FDP and wearing us. Thank you very much.